Just to introduce myself, I am Rajiv Kharka, a visualization researcher at Idaho National Lab. My area of research is VR, AR, 3D UI, and now I'm trying to learn more and bring 3D UI in digital twins. And then lastly, I would like to thank our mentors and reviewers who gave their valuable time to review the students' work, and today giving their time to mentor the students. I'm sure it's going to be really, really valuable to the students. As from my own experience, I was a DC student at 2016. Dr. Byrne was my mentor, so it was a great experience. Hopefully next year we can meet in person and then we can attend the DC. So finger crossed. I guess everything is hopefully going back to normal soon. So thank you very much, and looking forward to your presentations.
I can go next. Hi, I'm Jonathan Ventura. I'm assistant professor at Cal Poly out in California. And my area is like computer vision, machine learning, and applications in AR and VR. So I didn't participate in a doctoral consortium. This is actually my first doctoral consortium. So I'm very excited to be here. And thank you to the students and the mentors for volunteering your time, and especially to those of you for whom the time zones are not great. We did what we could, but there's only so much you can do. So thank you so much for being here. And yeah, really looking forward to a great meeting today.
Hey, thanks, John. So I can continue. Welcome, everybody. I'm Jens Kubert from Coburg University of Applied Sciences here in Germany. I have a professorship for human-computer interaction, and I'm also focusing on augmented reality and virtual reality, like most of you. And all I wanted to say again, the fourth time, thank you so much for being here. It's a great pleasure to run this doctoral consortium with you. And now let's get started.
I would like to add a couple of logistic things before we get started. We have Discord channel, we'd like to request if you have any questions after the presentation, to use a Zoom chat so that everything is in the same space, and then we can just monitor that easily. And also we save our time. The presentation time is 8 minutes and 4 minutes of discussion, so that I guess we will be monitoring the time. We'll be sharp on time, so hopefully you can limit your presentation at 8 minutes. And finally, for mentors, we have sent out a form, Google form. So in the email, so if you could check your email with the Google Forms and give your input at the end of each presentation, that would be really great. Thank you very much.
And we do have a schedule, and if you don't have access to it, it is available at the link that I just shared in the chat. Also, I wanted to take just a moment before we do our icebreaker and say, when we used to do this in person, it was pretty fun, and I shared a Twitter link to the picture from our Reitlingen conference for the Doctoral Consortium, where we started that whole speed dating thing. So where people did their handshaking introductions and moved around in a circle. That was fun, but we're going to try to do something where we engage you socially and just ask everyone to share their name, institution, and something about them that we wouldn't know. Likely, probably the easiest thing would be your non-academic recreational activity. And I will start with my non-recreational activity being, I am an avid gamer. I like role-playing games, I like tabletop games, I like video games. I like VR games the least, honestly, but I am an avid gamer.
Should we just pass it around, like you name someone and then we'll pass it to someone else?
Oh, sure. I'll name Jonathan.
Oh, okay. Well, my hobby is playing piano when I have time, usually a few minutes in the evening. I'll pass it to Jens then.
All right, so I'll share a small secret with you, not my hobbies, but my favorite food, but only when it's done by my father, which is mashed potato with onions and a beer sauce. But even though I don't drink alcohol, I like that very much. So I'll pass it on to Rui.
Hi, I'm Rui. I'm from Nova University of Lisbon. Well, my hobby would be lately board games and craft beer, like a nice combination. And I'll pass to Stephanie.
Hello, my name is Stephanie Solman. I'm an associate professor at the University of Otago in New Zealand. So actually this time zone or the schedule is in a good time zone for me. So that's great. Yeah, my hobby is actually surfing, and I started surfing in Lisbon, so that there's a good connection to Rui.
That's so cool.
Who are you going to popcorn to, Stephanie?
Sorry, I forgot about this one. Joe.
Thanks, I'm Steffi. Yeah, I'm Joe Gabbard. I'm an associate professor of human factors at Virginia Tech in the States. Yeah, I do a lot of AR research. So I'm going to go with something that no one knows about me as opposed to a hobby, because today's my birthday. Yay.
Happy birthday.
Hey, Joe, I'm going to clap so you actually can hear it.
Thank you, guys.
Happy birthday.
I'll pass it to Rick. Where did he go already?
I'm here. Thank you, Joe. And apologize for the noise. I am hosting a satellite event at Melbourne, and so I'm going to be on mute most of the time. But yes, I'm Rick Scarbez. I am a lecturer in computer science and IT at La Trobe University in Melbourne, Australia. And I guess I will go with I did improv and sketch comedy for almost a decade, which is why my PhD took so long. So that's are we just passing it to other mentors at this point, or should I skip over to a mentee? Oh, okay, I see a picture, and I apologize if I pronounce a name wrong or if I don't know you, because I probably don't. But how about Montserrat? If you're there, I would like to pass it to you.
Okay, I'm unmuted now. Hi, my name is Montserrat Alao-Shebikan, and I'm a PhD candidate at Tufts University. And my hobby is playing ping pong. And I'll pass it on to, let's go with Benjamin.
Hi, I'm Ben, and I'm a PhD student at Victoria University of Wellington. My hobby is running, and it is also my birthday paradox. Okay, so I'll pass it to Faisal.
Happy birthday, wow.
Hi, I'm Faisal. I'm a PhD student from Victoria University of Wellington, and my hobby would be taking pictures, I guess, yeah. And I'm gonna pass it to, sorry, how? Am I saying the name right?
Can you say it again?
YUCHAO. Okay, maybe Kyle Johnson.
Oh, hi, just joined a second ago, but Kyle Johnson from the University of Georgia, and I'm one of the mentors here. I don't know what exactly we're doing, but I'm assuming it's introductions.
That's right. And I think, Dan, you're trying to pass it to Yu Zhao.
Oh, and Kyle, you're also supposed to tell us something about you we wouldn't know, or your hobby that's not academic.
I mean, it's sort of academic, but I play a lot of Gorilla Tag. If you all are into VR games, you should try it. That's what I do on a regular basis for fun.
Yu Zhao, do you want to go next?
Oh, yeah, sure. Yeah, I'm Yu Zhao from Vanderbilt University. I'm a PhD student of computer science. Yeah, you can also call me Brooke if it's hard to pronounce. Yeah, I recently just restarted playing violin, so music always a good research mate. Yeah, I'll pass it to Shamo. Shamo.
Thank you, Brooke. So I am Shomojit Chakraborty. I am also a PhD student from the same lab in Vanderbilt University. And my hobby is like to travel a lot and take pictures and then put them into the contest. So I like to take part in the photo contest. So this is my hobby. So I would like to give what about Shakiba Daveri?
Yeah, thanks. Hi, I'm Shakiba. I'm a PhD student from Virginia Tech. And the last few months I've started bouldering and rock climbing. So that's a new hobby for me. And I'll pass it to Faiza.
Hi, I'm Faiza. Actually, my actual name is Zara. And so I'm a PhD student in Colorado State University, and my hobby is drawing. And I pass to, I don't know who is renamed, Verena. Did you spoke?
Yeah, hello, I'm Verena. I'm a PhD student at Coburg University in Germany, and I like to read science fiction novels. I choose Bernd.
Yeah, thanks. My name is Bernd Fröhlich. I'm a professor of virtual reality systems for 20 years, for more than 20 years at Bauhaus University at Weimar in Germany. And my favorite sports these days is kiteboarding, and I'm trying to be on the water as much as I can. Who else? Andrew.
I'm Andrew Maxim. I'm a PhD student in human-centered computing at the University of Florida. And my latest hobby is building and riding electric skateboards. And I will pass to Matt.
Hello, I'm Matt. I'm a student at the University of Central Florida. It's right down the road from you, Andrew. And I like to do things outside, whether it's skateboarding, hiking, rock climbing, anything, being in the sun. And I will pass it to Dr. Feiner.
Hi, my name is Steve Feiner. I'm a professor of computer science at Columbia. I'm interested obviously in VR, also in AR, 3D user interfaces, wearable stuff in general, as well as also 2D things. I've been doing VR and AR since it's a little scary, around 1989, 1990. And my hobbies are food and wine. And I came in a little bit late, so I'm not sure if anyone has passed it to her yet, but if she hasn't been heard from, I'm passing it to Gudrun.
Oh, okay. Hi, Steve. Hi, Steve and everybody. I'm Gudrun Klinker. I'm a professor of augmented reality at the Technical University of Munich. And my hobbies, oh, there are many. I like skiing. And recently I've also picked up lots of fun or interest in cooking. It may not be good yet, but I like it. And my husband has to eat it. Okay, I'll turn to Doug. Have you already presented?
No, I haven't.
Okay.
So I'm Doug Bowman, a professor of computer science at Virginia Tech. So I'm the third Hokie on this Zoom. Go Hokies. We got a big game tonight. I don't have any hobbies right now because I have a 5-month-old yellow Labrador Retriever puppy, and she takes all of our time. So I can't do anything else besides that. So I'll pass it to Sarah if she's here.
Hi, I'm Sarah Kramer-Gear, and I am a professor at the University of Utah in the psychology department. And I'm not a mentor here today. I'm just lurking because I work with a few of the students who are presenting. And so I'm happy to be here, and I would say I'll go with my hobbies of hiking and cross-country skiing to stay on the Utah theme. Oh, I'm sorry. I don't know who hasn't gone yet. I'm sorry.
Thanks for being here, Sarah. Yeah, who hasn't gone yet? Maybe Bobby Bodenheimer?
Hi, I'm Bobby Bodenheimer. I'm a professor of computer science at Vanderbilt University, and like Sarah, I'm a lurker. And my hobby, the one I'll talk about is I recently resumed bicycling after a long hiatus. I used to love it, and I quit for a long time, and I've taken it up again.
Great, thanks. I think we've got Faisal and Matthias.
Yeah, I can go next. I call myself. So I'm doing a postdoc at Northeastern University. I am from Argentina originally, and my hobby is I play drums. So Daniel, I think you're next.
I think Faisal and then Shu Wei, maybe.
I should continue.
Oh, yeah. Did you already go, Daniel?
Yeah, cool. So I'm Daniel from the Hong Kong Polytechnic University. I'm originally from Chile, and that's why probably Matthias nominated me. And yeah, my hobby used to be roller skating, but after pandemics, I'm doing more cooking probably. And yeah, I think I'm better in cooking than roller skating probably. So yeah, I'm glad to be here. And I'm not sure who we have left.
Maybe Faisal and then Shu Wei.
I already went.
Oh, you did? Okay.
So maybe
yeah.
Shu Wei.
Yeah.
Can do next. Yeah. Hey everyone, I'm Shu. I'm from University of Oxford, based on psychiatry. Currently a PhD student. So my hobby is I do stand-up comedy in my spare time. But today's presentation not going to be any comedy, unless it's like a joke. Hopefully no. So yeah, I don't know who else. I guess we're probably done with everyone, unless we've spoke anyone else.
Did we get everybody? I think we did. I think we're ready to get started. Thanks, everybody. It was really fun.
Yes, thank you. And one thing that I should let everyone know right now, so that you don't decide that you hate all of us DC organizers, is that we have a strict schedule. And we communicated that to all DC participants in advance, so they all know that they have 8 minutes for their talk and 4 minutes for discussion. Once people go over 8 minutes, we will notify them and have them stop, so there's time for Q&A. So I apologize in advance if you were one of the people that I have to cut off. It is in the interest of respecting everyone's time and making sure that everyone has an equal opportunity to present and get feedback. Thank you. And our first presenter, and I reshared the calendar in case people didn't have it. Our first presenter is Verena, how do you say your name?
Verena.
Verena Feiner?
Feiner? Yeah, it's
Feiner? Okay,
it's difficult.
okay, Verena Feiner. So that is our first presenter, and you should have the capacity to share your screen.
Yes. Okay. Let me just check. Okay, you can all see the screen?
Mm-hmm.
Okay.
Looks good.
Okay, so yeah, I'm Verena. My topic is about mixed reality interaction for mobile knowledge work. Yeah, with knowledge work, I am referring to work usually done on a computer or in an office. However, knowledge workers can also work in different environments, for example, at home or in a train or on a plane. They only need to bring their computers. However, in mobile or limited spaces, the productivity could be decreased due to hardware limitations. For example, they need to work on small laptops or tablets, and maybe they don't have a mouse or a good keyboard. And also due to the limited space and social distractions. For example, in the train, there could be other passengers. Mixed reality has the potential to solve such issues. For example, it provides some advantages like an additional display space, which can be used to display more information than on a small mobile device. It also provides a three-dimensional display, which opens up new dimensions for displaying the data. It opens up new interaction possibilities like gestures or spatially tracked devices. And of course, it's also possible to modify your work environment so that you like it. So far in my work, I focused on touchscreen devices because they are well suited for mobile scenarios and they are lightweight and don't require much space to operate. And we enhance them with the possibilities that VR provides. Related work has also looked at such advantages. For example, Gabbard et al. Describe how mixed reality can enhance and facilitate knowledge work. And Reordering et al. Showed that using an optimized virtual environment can reduce stress and improve flow by replacing an open office environment with a virtual environment. However, using MR also opens up some challenges, for example, how to efficiently interact with the very large display space or the 3D display. And current VR techniques like controllers or hand gestures might not be well suited for knowledge work because they're not precise enough, and they might not be practical in some scenarios. Like, for example, in small spaces, you cannot use large gestures. And conventional 2D techniques might not be usable in mixed reality or 3D contexts. Another challenge is if it's possible to use mixed reality for longer periods of time and what effects occur if you do so. So my research focuses on supporting knowledge work through mixed reality. And therefore I'm developing prototypes focusing on multimodal interaction and combining VR with traditional input devices. And I'm evaluating also such knowledge worker systems in user studies. Here's a quick overview of what I was working on so far. We already looked at how to support spreadsheet interactions in VR using a spatially tracked pen and tablet. We investigated how to navigate among multiple displays in VR. We looked at hand tracking accuracy of current head-mounted displays, and also we looked at how to support presentation authoring in VR. And I will now present some of those in more detail. So we conducted one study on how to efficiently interact on multiple virtual displays using a small tablet. So if you just use a small tablet as a touchpad, it would be very inefficient to move over these many displays. So we combined the tablet input with eye tracking. So as you see in the video, the eye gaze determines the active window, which is displayed with the yellow border. And a tablet was used as a touchpad within such an active window. And we compared that technique to a bimanual technique, where a second hand was used as a mode switch to enable switching through the windows. And we found that the technique, including eye gaze, was significantly faster and more usable. And we conclude that gaze is a valuable addition to the set of interaction techniques for mobile knowledge workers in VR. The 3D display can also be helpful for reordering stacked objects, for example, in a PowerPoint slide, where the objects are often occluded by one another. And in our study, we compared 3 techniques, which you can see in this video. Our VR technique, where the object layers were stacked on the tablet screen, slightly separated in depth, so that the user could use the pen on the touch screen to move the layers around and reorder them. And we compared it to the standard PowerPoint, which is shown in the upper right, which just displays all the layers in 2D and also presents a list with the names that can then be reordered. And then in PowerPoint for Mac, there's this option to display the layers 3-dimensionally on the 2D surface. And then you can grab the layers and move them around. And we found that the 3D visualization was much more efficient than both of the other techniques. And one reason was because the 3D view allows the user to clearly discern between the layers. So it's much easier to find the right layer. And this can be helpful in different applications involving layers or occlusions, for example, animation authoring or when editing images. I already mentioned that mixed reality also opens up new input possibilities. In our previous work, we used spatially tracked pens and tablets. For example, the tracked tablet can support the 3D view as it can be moved around to better see interesting objects and their relations, while it also provides precise input. And in our latest work, the spatially tracked pen was used for different tasks like object manipulation, interaction with objects, not just on the tablet screen, but also in air, like animation editor, where the keyframes were displayed in time, hovering above the screen. And you can also learn more about these techniques in my paper presentation on Tuesday. So far, we have seen how VR can be used to support knowledge worker tasks. However, we don't know yet which effects occur if you use VR for longer periods of time. So therefore, we also conducted a long-term study where participants work in R for a whole week. And we compared it with another week where the users were working without VR. However, this is currently under review, so I cannot give any details at this point. In summary, I have already looked at the interaction techniques for knowledge workers in VR using, for example, eye gaze, spatially tracked pens and tablets, and also depth visualizations. And I also looked at the long-term use of VR. And in the next step, I would also like to consider techniques for collaboratively working in VR, as this is an important aspect of knowledge work, and also expand the interaction techniques from VR to AR. Okay, thank you very much for listening.
Thank you. Thank you. I got kicked off of Zoom and I missed the end of your presentation, but luckily it's being recorded. So I will open up the room for questions. We have 4 minutes for questions for right now.
I have a question.
Okay.
So the very first study you showed, basically the gaze and different displays and metaphors of interaction. I was wondering if you measure cyber sickness and if this interaction metaphor can elicit this. What do you think?
Yeah, I think we measured it, but we did not find any significant differences. So they did not get more sick in the eye gaze condition than in the bimanual condition. If that's what you mean, yeah.
Yes, thank you.
Looks like Dr. Feiner has his hand up.
Hey, really neat work. I really enjoyed listening to that. I have a question about the space that's taken up by these displays. Is it sort of just in front of you? What is the horizontal and vertical field of view? Does it completely surround you? Can you see everything from one particular position? Or is it sufficiently large you might actually need to move your body or rotate significantly around you?
So you also mean in this study with the many displays?
Yes, right.
Okay.
So how many is many, and how wide and how high, and
So
how much sweet spot? Yeah.
In this study, we used 15 displays, and it was less than 180. I think it was about 160 degrees. So you only needed to rotate your head slightly to see all the displays.
Right. It'd be interesting to see, in regard to that earlier question about VR sickness, if you have to move a lot more, and especially if you're under pressure to move a lot more, you might see a bit more of that, especially with current tracking technology. By the way, this reminds me a little bit of an ancient piece of work that Hervé Benko did with me when he was my PhD student. It's 2005 Kai short paper, which is on using different approaches to move between 3 large physical monitors. And we had head tracking because we didn't have an eye tracker. We had special separate tablets in front of the display. And we also had the use of a mouse with some extra features to be able to go and move very quickly amongst them. Now, you might want to take a look at that.
Yeah, thanks.
Thank you. And one last question from Dr. Solman.
Thanks, Verena. It was really interesting. I'm very interested in the long-term use, and I know that you were saying that you can't really comment on this too much, but I would be interested. Can you say something about what your plan is with regards to actually having a study design for this? Or so I'm not really sure if I understood this correctly. So you already ran a study, or
so
how would this actually work?
We already run the study, and we just try to replicate a normal workspace in VR, and we use the Oculus Quest for that because it already provides also a keyboard that can be tracked and visualized in VR. And yeah, the people were basically just working like they would in a normal setup. Yeah.
Thank you.
Thank you very much. And thank you for an awesome presentation that engaged the users or the viewers. Thank you. And up next, Shakiba Davari. I apologize in advance. If you can tell us how to say your name properly, I will try to work.
That was perfect, actually. No, that was perfect.
Good.
Yeah. Thank you. Okay, thank you so much. So again, I'm Shakiba from Virginia Tech, and today I would like to talk about my PhD topic, which is focused on context-aware inference and adaptation in augmented reality. So in today's life, we all rely on digital information, and I think it's safe to say that we all use our mobile phones for a quick information access. But mobile phones have their own limitations. For example, they occupy users' hands, and their screen size limitations results in lower efficiency and higher distraction. More recently, with AR glasses getting lightweight and powerful, AR offers an alternative that can potentially use the whole world as their screen, and they can provide hands-free access to multiple pieces of information. Meaning that AR can offer a solution to many of the limitations of mobile phones. But still, AR interfaces introduce their own challenges. They can create visual clutter or affect user safety and awareness of their environment by causing occlusion and distraction. They can also create socially awkward situations, like this video from Autodesk.
Cool, so guess what? The funniest thing happened. Are you paying attention to me? I can't tell.
So having enough knowledge of the user's context, of who the user is, what their environment and their task is, can provide enough information to know the user's needs and wants and their limitations, which enables adapting the AR interface to provide the best information at the best time in the best form for the user, allowing efficient information access without creating new challenges for the user. As you can see in this figure, the virtual content can be prioritized without disturbing the user's primary task of reading. But when in a conversation, it must be transparent if it's not needed. And even when it's needed, it should not block the conversation partner's face. So my thesis is aiming to achieve 3 research goals. And the first research goal focuses on figuring out what is the proper adaptations or what is the best interface for specific contexts. And the second research goal aims to compare context-aware AR interfaces to non-adaptive AR interfaces and to current mobile phones in different contexts, and then validate the benefits that context awareness in AR can offer. And the last research goal, which I'm currently focused on, is aiming to provide a framework for design of such context-intelligent interfaces. In our previous work, we explored multiple adaptation dimensions. One was prioritization of real world versus the virtual content. Another one was adjusting translucency versus the position of the virtual content to make adaptations. And we also considered 3 automation levels from fully manual to fully automatic. And combining these design dimensions, we designed and explored 8 different interfaces in a real-world monitoring task or context, sorry. And our results validates the benefits of context-aware AR in this context. They showed that since here in this task, the task required users' awareness of the real world, the context-aware interface that prioritized the real world and automatically made the adaptations by adjusting the content's translucency resulted in better task performance, and they were preferred. In another work, we designed an adaptive interface for two different contexts. One for a solo context, which prioritizes the virtual content and provides non-obtrusive and efficient information access. And another one for a social context that prioritizes the real world, always ensures the visibility of the conversation partner's face and automatically provides access to socially relevant content. And comparing this interface with mobile phones and non-adaptive AR, our results validate the benefits of context-aware AR, showing that in both of the contexts, the context-aware was the least intrusive to the primary task, and it was the best in terms of information access, efficiency, user preference, and most of the user aspects. And if you're interested, I'll share more details on this work on Tuesday. So building on the existing taxonomy by Gabbard, currently we're working to propose a comprehensive description for user context that fits our goals. And we're trying to reverse engineer this. So we try to keep in mind all of the possible adaptations that an AR user would need to make in different contexts. And then we explore what information do we need to infer from the user's context to make these adaptations. For example, we need to infer the user's wants and needs, their desired virtual content and interaction techniques, and the appropriate time, place, and visual features for displaying the content. And then from there, we explore what context inputs would help us infer this information and we try to describe user context based on these context inputs. We believe that user context can be described by three main components: the user and their personal characteristics, user's tasks, and setting and environmental features of user's environment. So with such context-aware interfaces, we predict that a certain amount of machine learning would be involved as well, which gives rise to a need for data collection. So as my next step, I'm designing a non-adaptive interface for a selected set of contexts to collect contextual data and user adaptations. And then this study would aim to, one, provide a baseline for data collection for context-aware interfaces, and two, explore adaptive interfaces for those contexts and see what are the adaptations that most people preferred in each context. And here we aim to use our framework to choose a few contexts that have not been explored before. We will then upgrade our current context-aware prototype to include these contexts and then evaluate its potential benefits and disadvantages over non-adaptive AR interfaces and over current mobile phones. So overall, the contribution of this work will be to design context-adaptive interfaces for multiple contexts, validate their benefits in this context, and then propose a holistic framework for context-aware inference and adaptation in AR. Thanks for listening. I'd be happy to answer any questions here, and if the time didn't allow, please feel free to contact me with any questions, comments, suggestions.
Excellent, thank you. Great job. We will open it up for questions, and you're right spot on with time. Thank you. Dr. Bodenheimer has his hand raised.
Hey, thanks for the great talk. So could you just be a little more, when you talk about an adaptive interface, is the adaptation both in the sense of it moving around in the field of view and outside of the field of view, or is it an adaptation that is always on or sometimes on, and if it's both, could you talk about how you sense when it should be on and off, and particularly?
So if I understand your question correctly, by adaptation, we mean like any changes that you can make to the content to what the user can see. So it can be just turning a specific application on for them so they can see it. It can even be changing the fixation of that application. So like in a specific context, you want this application to be on the wall, fixed to the wall, but in other situations, you want it to follow you. And then like changing the translucency level of it. So like at times you may not need it, and then like just making it transparent. So I don't know if that answered your question.
No. So I got all of that, I guess, but how is that detected? Does the user do that, or is it automatically done, I guess is my question.
So the main goal is to do that automatically. So gather enough sensor data, enough like information from the user's environment and their task to make that decision, or to detect their context and then make the adaptation.
And so what are the inputs that you're going to think you're going to be using to make those decisions? That really is my question.
Yeah, so we're trying to come up with a huge list, and this is like the work in progress. So we don't have like a specific, like a complete answer to it, but the inputs can include, so like for the last study we did, the inputs were the conversation detection or speech detection from like what is the user talking about. And it could also be like the image processing and taking a picture from what the user can see in front of them, and then using that to like detect if there's a face in front of them or not. But there's of course a lot of other input relating to like the user, like it can be just users' personal data, their calendar events and everything. It can be anything about their environment, their location, the timing, etc.,
Okay.
etc.
All right, great. Thank you.
Thank you.
Thank you. And we have time for one last question from Dr. Grunberg.
Shakira, thank you so much for the nice work that you are doing. And because you were actually referring to one of the works of Stephanie and me, I have to ask a question here. So, so far what I understood is that this adaptations that you're doing likely relates to adaptation on a single device, right? Either on augmented reality smartphones or smart glasses. And I was just wondering if you are also considering adaptation beyond the bounds of individual devices, like if you would switch, for example, between, let's say, an AR glass and a smartphone, if you have done any work on that, or if this is still on your schedule, or I would just like you to comment on that a little bit.
Yeah, thank you so much. That's actually a great question. For my PhD, I wouldn't be like going too much out of that, like the one device situation. But I think like the overall goal is that like it's kind of an Internet of Things. You get all of the information from everywhere, but like you're sharing that that system between different devices. But it wouldn't be something that I am considering so far, or I've been considering so far, or I would like work on.
Okay, thank you so much.
Thank you.
Thank you again for a great presentation.
Awesome. Thank you.
And up next, Faisal Zaman. Or actually, no, I'm skipping someone. I'm so sorry, Faisal. It's Sumajit.
It's Somajit Chakraborty. Yeah.
Thank you, Sumajit. So Sumajit is up next, and we are ready for you to share your slides or screen whenever you're ready.
Can you see my slides?
Yes, we can.
Okay. Hi, everyone. I am Shomo, a PhD student from the Live Lab at Vanderbilt University. Today, I am going to discuss about a brief overview of my research proposal, which is effects of asymmetric locomotion methods on collaborative navigation and wayfinding in shared virtual environments. Let us suppose that a group of people wants to travel to a place from their current location. So what will they do? They may form a strategy about the route to the destination first. Next, they can use a form of locomotion to move. Next, they may update their route strategy while navigating because of various reasons like traffic jams, roadblocks, etc. And thus they will reach to the destination ultimately. This overall process can be termed as collaborative navigation and wayfinding. For example, many a times we can see that a passenger can guide the driver of a car by following a map or any form of instructions of the intended route to travel from one place to another. Given that people often perform collaborative navigation and wayfinding in real world, I want to see how people can collaboratively navigate and wayfind in a virtual environment in general. Now, while considering multiple people in a virtual world, we face two important questions among many others. That is, how do people experience the virtual world collaboratively? And how do they locomote through the virtual world collaboratively? To experience the virtual world collaboratively, the environment can be shared among all the people so that they can experience the same environment at the same time. However, answering the second question is difficult because all the members of a group may use either a symmetric locomotion method such as joystick or teleportation, or each one of them may use asymmetric or different locomotion methods such as joystick with redirected walking. There has been a significant amount of research in collaborative tasks in terms of locomotion methods, interaction, spatial learning, effects of leaders, avatar interaction, presence, and much more. However, if we consider the locomotion methods in general, we will find that all of the previous studies are based on symmetric locomotion methods. To my knowledge, there has not been any prior research done in the field of asymmetric locomotion methods. So given from the prior literature that different locomotion methods affect acquired spatial knowledge differently in virtual environments, and dyads perform better than individuals in acquiring survey knowledge using symmetric locomotion methods, I want to see through my research how do different locomotion methods affect the acquisition of survey knowledge for collaborative navigators in a shared virtual environment. To find out the answer to this big question, I will set up 3 consecutive experiments to answer 3 research questions, which I will be discussing shortly. In each of my experiments, I will use the virtual maze environment by Castile and Warren's acquisition of survey knowledge experiment. I will change the maze slightly to test individuals and multiple people. People need to walk through the virtual mazes to remember the locations of various objects placed at various places in the mazes during the training phase. During the testing phase, people will be placed in an empty desert environment, which will be free of any cue from the virtual maze environment to estimate the direction and distance of one object from another. So the main independent variables of my overall research are different locomotion methods and number of objects to learn in the maze. And the main dependent variables of my overall research are angular error, distance error, and recall time, as previous research used these variables as the metric to measure survey knowledge of individual dyads. Let's discuss about the first research question, which states if a locomotion method performs worse than another locomotion method for individuals, will it still hold for dyads? This research question will establish a basic understanding of the effects of 2 asymmetric locomotion methods on dyads in collaborative navigation. To answer this question, I will choose 2 different locomotion methods, that is joystick with body-based rotation and resetting. Using these 2 locomotion methods, I will compare the acquired survey knowledge of individual navigators of a dyad with the overall acquired survey knowledge of the dyad as a unit. Now there are mainly 3 reasons for using these 2 locomotion methods. First, I want
Break is at 10:45 to 11.
I want to use physical walking as the constraint between these 2 chosen locomotion methods, as people do not physically walk in joystick locomotion method, whereas in the resetting method, they physically walk. Second, As previous research showed that dyad acquire survey knowledge better than individuals using joystick with body-based rotation, I chose this locomotion method as one of my test methods. And finally, I chose resetting as it can be the closest real walking simulation performed in our lab space. The two main expectations that I am willing to see from this experiment are that dyads perform better than individuals using asymmetric locomotion methods as well, and symmetric joystick performs worse than asymmetric locomotions, which performs worse than symmetric resetting, where the letters represent the locomotion methods used by dyads. The second research question checks if a generalized hierarchy of locomotion method performance exists in case of individuals. Does it still hold for dyads in terms of acquiring survey knowledge? To answer this question, I will introduce walk-in-place locomotion method along with the other two locomotion methods that are used in research question 1. And like research question 1, I will compare the effects of these locomotion methods on individuals and dyads in terms of acquired survey knowledge. The main reason for introducing walk-in-place is that it is a form of a hybrid locomotion method where people need to simulate physical walking while standing at the same place. Finally, as previous studies showed that joystick performs worse than walk-in-place and walk-in-place performs equivalent to resetting for individuals, I expect that this relationship will hold for dyads. The third research question states, if there are more people in a group rather than 2 persons, will the previous findings still hold? The main reason for checking the effect of asymmetric locomotion methods on increased group size is that presence of a leader in the group can affect the overall group performance, which has been shown in several previous studies. To answer this question, I will use the 3 locomotion methods that I used before to answer research question 2. And this time I will compare the acquired survey knowledge of triads using symmetric locomotion methods with the triads using asymmetric locomotion methods by each one of them. I expect 2 main findings from this experiment, which are, if there is a leader and he or she uses an inferior locomotion method, the overall group performance would decrease and vice versa. And lastly, if a certain locomotion method performs worse than another one for dyads, it will hold for triads also. Overall, using 3 research questions, I would like to investigate the effects of asymmetric locomotion methods on collaborative navigation in a shared virtual environment. I'd like to thank our sponsors to support my research. I'd like to thank you to listening to me, and thank you. If you have any questions, I'm happy to take them now.
Thank you. Thank you so much. Very interesting topic, and I see applause around the chat. Are there any questions?
Sure. I raised my hand. I don't know if you can see that.
Yeah.
I didn't see that, sorry.
Oh, okay. Yeah, very nice work and very good presentation. I didn't get all this information from your paper that you submitted, but now it has become more clear. So you want to actually have the group stick together basically during the whole task, as I understood now. Okay, that makes a lot of sense. So one question obviously is, why are you not using short range teleportation, or what we sometimes call jumping, as one of the methods? Because it's just like one of the most used methods overall, and the other one is steering, of course. So why not using teleportation?
So to answer your question, I need to go back to this. So as you can see, I am considering physical walking as one of the constraints of my choosing of locomotion methods. Now, if you consider the teleportation, basically you are considering a continuous locomotion method and comparing it with a discrete locomotion method, right? Or like the jumping locomotion method. So so that's why, like, if you are considering, and I also think like there is no previous study which has shown comparing a discrete locomotion method with continuous locomotion method in terms of dyads.
That exists, that study, and it shows that spatial orientation is similarly good. I can show you a paper that actually shows that. So it's quite similar for these two methods. And so I would not expect much of a difference for the different combinations, steering
based methods. Why are you actually calling it joystick based? It's steering, right? But maybe it's like a common term in some areas. But I would say you're using rate controlled steering to navigate, so continuous method, and then you have walking. But in walking, you always have the hypothesis that walking is the best with the resetting method, real working with resetting. But you're very much affecting the sense of orientation by resetting, right? So that I would doubt that to a certain extent. Depends on the environment, but don't you have any doubts about that? Because of by resetting and affecting the orientation, sense of orientation of the participants.
Yeah, that makes sense, but still, like the best way to judge the walking, the physical walking will be like the redirected walking. So, but we still do not have that much of lab space to run the redirected walking in our physical space. So if we want to run a physical walking experience, then resetting will be a better choice for our lab space. So that's why I have used.
But for ecological validity, I think maybe teleportation would be a better choice, but I don't know. Okay. I have to hand over. Steve is also.
Quick question. So one thing that I've really been impressed with in doing studies of people's abilities to understand space is there's a huge variation, for example, ability to do mental rotation. And so I think another variable here that you might want to think about is a variable between people. And that if you match people, if you know something about how they can navigate two navigation techniques, you might find a heterogeneous combination that's much better than giving each individual person the same thing, let alone giving person who does something really well, something that gives them the information about something they don't do well and vice versa.
Yeah. Okay.
So you might want to measure individual abilities to go and do navigation when you make the decision about how to assign them, and also in evaluating how well the techniques work.
Okay. Okay. Thank you. Thank you.
Okay, thank you. Thank you so much for the great questions. And thank you for the great presentation. And we have next on our schedule, Faisal is actually next this time.
Can you see my screen? Okay.
Yes.
Sorry. Thanks so much. So I'll be presenting my doctoral constitution paper titled Improving Multi-User Interaction for Mixed Reality Telecollaboration. My name is Faisal Zaman from Victoria University of Wellington, and my supervisors are Professor Taryn Ree and Dr. Craig Aswell. Oprah Winfrey, the celebrity talk show host and billionaire philanthropist. During the pandemic, she, like everyone else, was stuck at home and couldn't go about her daily activities. Here's the picture of her meeting with the teams during the pandemic. Right now, we all can relate to this picture. Actually, this is what the typical remote collaboration looks like. We open up Zoom and we get a two-dimensional video stream of remote user, where most of the camera have limited field of view that can constrain how information can be presented. Although it works well for face-to-face conversation, but it limits us to see other people's body language and gaze. Also, our viewpoint is restricted based on the placement of the physical cameras. So if you want to bring the environment as a subject of your conversation, you have to move the camera by yourself, which is not engaging, as the user have no control over where to look. So to put it in a nutshell, the current system lacks the spatial presence and social presence. Clarify, the spatial presence is the feeling of being transported in a mediated space where you forget that there's a technology between you and the virtual world. So it feels like you're really there at the remote location. On the other hand, social presence is the awareness that you are communicating with another person in a mediated communication. So if I plot a chart between the type of communication and the effectiveness of the communication, the textual communication, like the letter writing, has the least social presence, where the face-to-face communication has the most social presence. In case you're wondering where the video communication lies, is just right below the face-to-face communication. So now if I can go back to this picture one more time, we can see that she's not just talking with the remote user. She also has a marker and piles of document that she has highlighted and shares with the team. because interaction is also a huge part of remote collaboration. So to recap, the questions there is, how do we know that we're talking with the people without face-to-face communication? How do we present ourselves? How do we form relationship? How do we create a personal interaction without seeing somebody? And the key solution to this problem is to look into the mixed reality remote collaboration. Mixed reality approaches offer merging of real and virtual world to create a new environment for real-time interaction. So this is the focus of my PhD. In my thesis, I'm developing a multi-user mixed reality remote collaboration system to allow multiple users from co-located and remotely located space to teleport into a collaboration space. So to put into perspective, in time and space metrics, the collaboration scenario targeted by this research lies in the same time and different quadrant. Same time and another place quadrant. As you may have noticed, this is an interdisciplinary research. It has spread over several areas. Our focus is on the intersection of XR, CSAW, as well as the intersection of XR, visual analytics, and CSAW. So to add more context, we are focusing on asymmetric mixed reality remote collaboration, where the user in real space using AR headset and interact with the remote user who are using VR headset. So I investigated the Relevance study and conducted a systematic literature review as a part of this PhD research. For those of you who love numbers, you might like this. We found 556 papers that employ mixed reality collaboration technology between 2000 and 2020. We collected them from 112 publication venues and from 12 data sources. So after that, we classify them by the input type, then the interaction, cue type, evolution type in the user study. So this gives us a complete picture of the pipeline of mixed reality remote collaboration. So the review shows that the interest of mixed reality collaboration is growing, but there weren't many papers on multi-user mixed reality remote collaboration, which I think is due to the prerequisition of real-time performance, high accuracy, and low latency. And there's also a need for accurate and specific data modeling, which provide especially detailed information. And lastly, the multi-user mixed reality collaboration aims to bring experts from different domain fields to utilize their knowledge, which requires exploring new interactive issues like collaboration, coordination, and communication. So our research question becomes, how can multiple remote VR users effectively connect and collaborate with local users in one or more mixed reality spaces? And to elaborate that, we actually broken it down into several additional research questions, like how do multiple remote users have a special presence and a special awareness in mixed reality collaboration space? How do we represent them? And then how do support multiple users so that they can interact with each other? And last but not least, we're asking the question about viewpoint perspective. How can we effectively manage the viewpoint perspective of multiple users? So since we're building this fantastic system, we need to evaluate the quality of communication. We want to see if there is a benefit of using this kind of system over the desktop conferencing or other tools that exist. So to do that, we combine the qualitative and quantitative analysis. So we hypothesize that the social presence and spatial presence will be higher in our system. And we think that because our system will allow users to see each other, and at the same time, they can explore the real environment of the user. So the social presence and the spatial presence should be higher. We also think that our system will have high usability in collaborative tasks. And we measure that by the standard usability questionnaire. And we think that because our system aims to improve the usability of the task-oriented tools and actually provide them some specific tools for collaboration. And lastly, we think that our system will have higher task performance, and we measure that by the solving time and the raw TLX. So in conclusion, we're asking a question about where we go from here. And so right now, I'm keen to know that is there a need to narrow down the topics or focus on something specific that is missing? Also, are their planned experiment adequate or need to be revised? And I want to end by saying that the great sci-fi movies like Star Wars have featured holographic messaging teleportation almost 50 years ago. And mixed reality remote collaboration is so close to transforming today's text-to video conferencing into a life-size virtual television system, where the concept of teleportation is no longer a distant fantasy. Thanks for your attention.
Thank you. Thank you very much for a great presentation. Very interesting and engaging. And there are hands up. Dr. Scarba's hand I see up. And I see lots of applause.
Yes, hello, good morning. Thank you for an excellent talk. I'm just, so this is not to try to be difficult, but so what is the relevance of spatial presence in this application? Because spatial presence is usually used to discuss being taken to another place, right? Rather than just interacting with another person, maybe even in a shared space. So that's the question.
Because we're focusing on the remote collaboration, so we assuming that the people are actually located like in another place, and so sometimes you need help, and you're maybe working in your office or workspace, but the expert is not with you in the physical space. So we need to bring this expert in your office so that he can have a special presence of the office and equipment that you're working, so he can help you to guide you whatever you're doing. So that can be one thing. Or also in industry, people spend a lot of money for training people. So if we can bring those people on your space, then it will be easier to train them without being, or maybe like traveling to the workspace.
Okay, thank you. I think I misunderstood what you were trying to accomplish at first. So thank you for the answer to that question.
Thank you. And I think Dr. Bowman's hand was up next, and then Dr. Klinker.
Yeah, thanks. So thanks for the talk. I'm sorry if I missed it, but most of your hypotheses were about the comparison between your system and other sorts of approaches for telecollaboration. But I didn't completely understand what you were proposing your system to be. Can you just explain briefly the user experience in your system?
Okay, so in my system, I'm trying, like the system we're developing will allow multiple people to be teleported into a real space, and they can actually collaborate with the VR and AR user like at the same time. So to do that, we are comparing with the existing system that already allowed. For example, we have 360 video camera system that allow you to see the real space, also have point cloud-based system, and also 3D reconstructed system. So comparing them to see how effectively you actually solve your tasks using our system comparing to the other system. So that's the one aspect of the spatial presence. And the second part, we're looking into the viewpoint perspective, because when you like multiple people in the same place, they each have their own viewpoint. Means because it's a 360 environment, so they can look wherever they want. So we try to manage their viewpoint perspective so that everybody can understand where you are looking at, rather than you have to look at the avatar or look at the screen what is looking at. So we're also trying to compare how effectively we can manage the viewpoint perspective of multiple users.
Thank you.
Thank you. Dr. Klinker.
Yes, hi. Thanks for the very interesting talk. Initially, you showed a picture of a lady who was looking at, I don't know, dozens of people like us right now in our doctoral consortium. Do you plan for your own system to be scalable to that number of people, or how many people should be using your VR-based system?
Yeah, that's a great question. I think the scalability is a huge like challenge for my system. But for right now, we have some sort of workable system which allows at least 5-6 people to join. But as we move to this PhD project, we have planned to see how we can scale this system, so to allow maybe 50-20 people there. But it's a very challenging issue that we are still trying to address.
And each of them will be represented in some spatial form as an avatar or something like that?
Yes.
Or maybe.
Sorry. So if the person is in the another location and he wants to teleport, then he will be actually presented as avatar. So you will have a bunch of avatar like moving around in your space.
How does this compare, for instance, to Virbella or Hubs, Mozilla Hubs, or other telecollaborative tools, GatherTown, that are popping up left and right?
So one of the main difference in our system is we have spatially awareness. So you are actually in the real space, not into the virtual world. So you actually real space in the real location. You can see, look around your environment and the object around you, which is kind of the main differential between the normal system.
Okay, thank you.
Thank you. Well, Dr. Feiner has a question. We are out of time for questions, but we do have a little bit of time in the schedule because we haven't had transitions between people. So we'll take one last question from Dr. Feiner and then transition to the next speaker.
Okay, so in the grand tradition of how does this compare with things like Spatial, for example, or some of those hypothetical Mark Zuckerberg meta turning into Facebook turning into meta videos that were posted to YouTube that show people interacting in a combination of the real world and a virtual world?
So first of all, you will be able to share your environment, which I think like the other example is Spatial and other like Vibrella doesn't allow. And the second part would be
no, excuse me, Spatial. I didn't. This vSpatial and Spatial, they're completely different companies, and Spatial, does let you have an avatar in your actual physical environment. So it really is AR.
But I'm not quite sure if the Spatial allows you to share your environment in 360. I'm not quite sure, so I cannot comment on that. But my understanding was the difference between the other system and my system would be you can actually stream your environment in live, where the other user can see your environment. So it will feel like he's actually next to you, and he can see your workspace, your space in real time.
I mean, because there are people who have been working on stuff like that.
Oh, yeah.
Well, thank you. Thanks for the great feedback, and you will have time to talk with your mentors as you have scheduled. And thanks for the great questions to the mentors. On to the next speaker, who is Shui.
Yes. I'm just making sure. Cool. Hopefully everyone can hear me now.
Yes, we can.
Cool. Thank you. Hey everyone. So this is Shu from University of Oxford, based on the psychiatry department. So today I'm very happy to share my research about using facial expression on virtual human to optimize mental health VR therapy. So social interaction actually accounts for more than 30% of the time when we are awake, and it actually affects our mental health state. Virtual human are an essential element to create social interaction in mental health VR. As an important component of virtual human, facial expression actually are the charms which bring the emotion and personality into the virtual human. And creating facial expression requires understanding of facial dynamics from both the technical and psychological perspective. However, the reality is today, 90% of mental health VR remain utilizing the neutral face virtual human rather than implement dynamic facial expression. So this is partly due to the complexity of facial animation modeling, as they can be quite expensive in terms of time and resource. It contains the process of 3D character modeling, rigging, texturing, and animation pipeline. Meanwhile, we also have limited understanding of how emotional facial expression are actually processed in VR, especially with the people who have mental health difficulties. And all this component actually sets the challenge for the VR content creators and psychologists to enhance the efficacy of VR mental health therapy. Therefore, my aim here is to implement dynamic facial expression on virtual humans and try to explore their potential to enhance the efficacy of VR mental health therapy. So to further breaking down this aim, we have the below objective. To start with, I like to understand the use and potential of virtual human character and the facial expression in immersive VR to advance mental health research. As a technical component, I will also create and implement contextual related facial animation on the virtual human in VR and try to gather users' responses through the real experiment. And lastly, we want to looking at impact from the psychiatric perspective. So we want to examine what the potential moderate effect of people's mental health states, for example, mistrust tendency, paranoid thinking on their responses towards the facial animated virtual human. So to start with, we conducted a systematic review looking at all the application explicit using virtual human in mental health VR through empirical research. We found 62 studies. So when looking at the role of virtual humans, they're predominantly serving as the active social interaction partner, which is basically the virtual human interactively engaged with the user, aside from the other use case, such as virtual buddy, virtual crowds, and virtual coaches, which used to automate VR mental health therapy. And looking at mental health difficulties, we found out social anxiety, eating disorder, psychosis are highly using all this kind of virtual human for mental health VR. So what are the characteristics of virtual human are being used in mental health VR? With this question, we also found out virtual human static features such as gender, ethnicity, and body size are more common in terms of manipulation study. However, in terms of more complex features such as emotion, facial expression, only 10% applications are actually using it, and the technical complexity and impressiveness are generally low. Therefore, we have planned 3 empirical experimental studies to further looking at how we can best use facial expression on virtual human for mental health VR. So our first experiment looking at facial expression on a virtual coach. And this study looking to examine whether the particular nonverbal behavior of the virtual coach can affect people's engagement of the VR mental health therapy. So here we designed and developed a virtual fear of height program to basically provide people who have fear of height tendency a VR experience. So this program contains 2 things. Well, the indoor thing, which is a VR consultation, where the user will be invited to talk to a virtual coach, which as the left-hand picture said. And followed by the consultation in the inside room, the user will also invited to try out a virtual height experience in an outdoor VR experience, which as the right-hand side picture says. So based on this program, we want to look at 2 questions. So the first question is, we want to know whether the addition of facial expression and head movement can actually enhance the therapeutic elements and also the perceived expectancy of the VR therapy. As the secondary question, we also want to looking at, is there any moderate effect of participants' mistrust tendency on their therapeutic elements with the virtual coach? So before I dive into the study design, I would like to share a 10 seconds clip. So that is what 2 out of the 4 group of the participants experience for the first 10 seconds when they experience this VR consultation.
Welcome. This is Now I Can's step-by-step guide to feeling much more confident around heights. Before we get started, let's make sure the system is set up correctly.
So have we actually spotted any differences? Hopefully yes, but hopefully also not that obvious. So
welcome.
Sorry. in terms of the experiment design, basically we got adopted a 2x2 factor. So the independent variable is first about the warm facial expression. And the second element is the affirmative head nod of the virtual coaches. So just as the example shows, we actually present the first condition where a neutral face coach without affirmative head nod, while the right side is actually a warm facial expression coach with affirmative head nod. In terms of the measure, we're first looking at the therapeutic endless and willingness to continue the treatment through a questionnaire measurement. Besides that, we are also collecting the supplementary data to making full capacity of the VR technology. We will look at the VR behavioral data in terms of users' head movement, response time when interacting with the virtual coach. At the same time, we're also collecting the physiological data, including the heart rate and the EDA, including the skin contact level, especially when the participants experience outdoor experience and show their hesitation when walking into the virtual plank. So this is a still ongoing study, and we're looking to recruit 120 people randomized to 4 groups, which is quite ambitious for the COVID time. So finger crossed for that. So aside from this study, we also have future study under planned to looking at individual difference in interpreting the dynamic facial expression in VR. We're especially interested of the faces of virtual crowds, which we aim to examine use the eye tracking method, and also the faces of the virtual baby. So just to summarize, this multidisciplinary research actually contains multiple elements to combine VR with mental health research. So the first element is about conduct systematic review of all the empirical evidence of how we're actually using VR safety in the mental health domain. And the second component is about VR and virtual character, which ranging from the facial animation, from the combined method of blend shapes, video retargeting, and motion capture. And we aim try to create a realistic facial expression which fit the context. And the third element is basically experiment where we collect the real data and try to assess people's behavioral, psychological, and physiological behavior to further understand how people exactly perceive the emotional phase in VR mental health therapy. So that is end of my presentation. Thank all of you for listening, and I'm happy to share more feedback and question. Yeah, that's all. Thank you.
Thank you so much. Great presentation. And you have lots of hands up, but we only have a couple minutes for questions. So Jens, did you notice you had their hand up first? Because they all seem to pop up at the same time for me.
Alicia, who are you referring to? I didn't put up my hand, I guess.
No, I was asking you if you saw who had their hand up first. We'll just
no,
start
no,
with.
sorry, sorry.
Rui is at the top left of my screen, so I'll assume that means he was first.
Okay, thank you. So Shu, do you think there's a danger of getting to an uncanny value, like where by making the face smile, but with a robotic voice, the character looks more creepy and people disliked it more? And would it be better if the smiling face would be controlled by a real human voice, like with some twists and not so much of a robotic sound? Do you think that, do you have that danger, and can you improve by something like that?
Yeah, thanks for the question. I think that's exactly kind of like one of the motivation behind this research. As in today, we actually, first, we even don't know whether people actually notice the change of facial expression or not. And also, especially in the domain of mental health research, we don't know whether when your facial expression is not consistent with the voice, or not only in the voice, maybe like their texture, their realism, their random quality, people may perceive like quite old experience, as some of us may refer to like uncanny valley, or more especially if we're working with the people with mental health difficulty, such as paranoia, psychosis, that actually can cause like bigger of the trouble, which I wouldn't say even like unpleasant or something, it can actually create a real problem for them to even like reinforce their mental health condition. So that's why we try to first looking at whether people can actually detect the facial animation changes, and also like whether what we think is warm are actually perceived as warm for the people who don't really have any clue at the beginning. So yeah.
Thank you. And we'll go to Dr. Feiner, and maybe we'll have time for Dr. Bodenheimer since our session is over at 45 minutes after the hour and we only have one more presentation.
Okay, so really enjoyed listening to this because it's obviously really important. I think of certainly for remote stuff, a gold standard being video, a direct video. And in a therapist relationship, there would seem to be no reason not to do that. So why have you thought about comparing with a direct video conference, or for that matter, with one in which, independent of what the avatar looks like, there's a little video inset that lets you see, again, the actual image of that person's face?
Just to clarify the question, because I don't think I fully understand.
Sure.
You mean like compared to a real virtual, compared to the real coach through like video, compared to the avatar? And
video of the real coach, right, compared to the video of the coach avatar, no matter how good the facial modeling and interaction is. And even independent of that, actually including, excuse me,
yours?
Including an inset of video in the virtual environment. So you always have the reference of the actual real face. I was wondering if you might want to think about that as being a possible comparison condition.
Yeah, that's actually, I would say we actually partially adopted. So we haven't really fully implemented to kind of like compare like a real virtual therapist, a real therapist with the virtual coach. But when we're building our animation for the study, we actually capture a real like therapist, capture her facial expression and try to project in the virtual avatar, and to do kind of like a combination of the blend shape and video retargeting. So in terms of technology, that's kind of what we do. But in terms of comparison of how, you know, video call with real therapist versus the virtual agent, I think that's also one of the motivation, as saying, although like with the video call become like so easy to connect each other, but still like a sense of presence. I think that's probably could be another whole new topic. And at the same time, like one motivation of creating this virtual coach is actually for the people who even not have access to video call with the real therapist. So that's maybe a problem or opportunity to this like lack of resource. But yeah, it's definitely a good, I would say it's good, another big research topic to looking at. Yeah.
Thank you.
Thank you. And if Dr. Bodenheimer's question is not terribly long, we could do that before we get on to our last speaker.
Thanks. Thanks for the nice talk. So there are theories of facial expression and emotion recognition that indicate that eye gaze and is important. And I didn't see you consider that. Did I miss that, or are you considering that?
Yeah, so in terms of eye gaze, so we actually planned the second study. It's dedicated in terms of try to detect like users like eye traction, but I assume you also mentioned like the eye gaze of the virtual coach.
Yeah, I meant the eye gaze of the avatar.
Exactly. So when we decide even like just like the 10-second clip, maybe it's not like a very good full presentation, but we're basically using kind of like a tracking function, basically you're tracking where the user's standing point. And then we're kind of like mapping the eye gaze towards the user direction, but also with a little bit kind of like the bending filter, because when you are 100% of time looking at a person, that can cause paranoid thinking too. So we actually adapt in the condition where when the virtual coach have the noting, she was still looking at the participants like 40% of the time while she's not noting. So that is something we do.
So your model has that. That's great. All right, thank you.
Thanks.
Awesome, outstanding presentation. Thank you again.
Thank you.
And Our next presentation before the break is Neil. Yeah, I think that he's here. It's a message maybe. Neil Williams.
Hi, yes, I'm here.
And you're sharing your email. Okay.
Yeah, here we go. You see my slides now, right?
Yes, we do.
Okay, great. Hi, I'm Niall Williams. I'm a PhD student at the University of Maryland, College Park, and I'll be talking about robust redirected walking in the wild. So with VR locomotion, ideally, in a lot of the cases, we would like to let users explore the virtual environment using natural locomotion, but this is because it has lots of benefits for things like task performance and immersion. But this is not always possible because the layouts of the two environments will be different. And so some paths in the virtual world may correspond to obstructed paths in the physical world. So one way to help alleviate this problem is with redirected walking. And what redirected walking lets us do is it lets us decouple the shape of the physical path from the virtual path. And so essentially what we can do is steer the user around in the physical space to help them avoid objects that they can't see because they're wearing a HMD. And with redirected walking come two big questions, which are first, where to steer the user in the physical space, and then second, how much to steer the user. So for where to steer the user, for any given virtual path, there's a range of physical paths that we can steer the user on, and some may be better than others because they may avoid all collisions or maybe have fewer collisions than most paths. And then the problem there is figuring out which path is the best one to steer the user along. And then for how much to steer the user, redirected walking, it relies on the user's perceptual system and their ability to discriminate rotations. So the faster we do rotations of the virtual world, the more steering power we get, but the more likely it is that users can perceive these rotations and it'll probably make them feel sick and it'll detract from their experience. So it's very important to know how much redirection or steering can we do before users start to notice it so that we can deliver a comfortable experience for the users. And my thesis is focused on making progress in both of these areas. So for the first question of where to steer the user, there are two main problems I'm looking into. So first, there's an issue of generalizability. So lots of redirected walking algorithms that have been developed, they work well in the environments they test in and that they were designed for, but it can be very difficult to get these algorithms to perform well in other environments. So here's an example. If we have the algorithm steer to center, which just steers the user towards the middle of the physical space at all times, this works pretty well in convex environments with no obstacles. But once you add, say, an object in the center of the room, things get very difficult because you're going to be steering the user directly into an object. And it's not really clear how to adapt steer to center to make it work in not just this environment, but other environments while still being sort of reminiscent of what the actual steer to center algorithm is. So it's hard to apply it to other environments. And then the other issue is that a lot of algorithms in this space tend to ignore the layout of the virtual environment, which is a bit of a weird limitation, I think, because the VR locomotion problem is interesting, or it's a problem in the first place because the layouts of the two environments are different. And so by paying attention to both the physical and the virtual layouts, we get more information to hopefully help us steer things better. And here's an illustration of this. So we have two environments here, physical and virtual, and they have different layouts on a global scale, but on a local scale relative to the user, they're the same. And so actually, in this case, the user would be able to walk straight forward without any collisions. And ideally, an algorithm would be able, a redirected walking algorithm would be able to recognize that these two environments are the same locally and that it wouldn't really need to do any steering in this situation. But a lot of algorithms these days, or so far, are not really capable of this because they don't look at the virtual environment. And so to help tackle these two problems, I look towards motion planning. So this is a field in robotics that has been studied for decades, and it's basically just concerned with how to get an agent from point A to point B in some environment. And it turns out it works very well for the redirected walking problem as sort of language to do things. So it provides a language that we can use to formalize redirected walking algorithms and environments, which makes things easier for us. So with motion planning, we have an environment and some agent in the environment, and there's a goal position. And we want to use motion planning to find the path to take the user or the agent to that goal position. And this can be extended to VR, where we have a user in two environments. They travel on a virtual path, which corresponds to some physical path. And then we want to use redirected walking, aka motion planning in this case, to figure out a path in the physical space that avoids collisions for the given virtual path. And so the goal with this part of my thesis is to develop motion planning based redirected walking algorithms that work in arbitrary environments. So regardless of the layouts of the environments. I have some work towards this already from last year at VR and ISMAR, where we presented some algorithms that do some analysis of the shapes of the environments in the physical and virtual and try to steer the user optimally based on those environment layouts. And then this year I have some work looking into what are some good ways to actually measure the differences between the two environments and then leverage that for algorithms later. And so the next part of my, actually, here's a very quick demo of this that I actually got working a few days ago, actually. So it's very, very early, but this is sort of to give you an idea of what we'd want to do. So that blue mesh there is the physical space. That's like that's the floor that the user can walk around in. And then it's overlaid on top of a virtual environment. Ideally, we wouldn't actually show this to the user. But I'm showing it here for visualization purposes. And so the idea is to use the mesh in real time in conjunction with the virtual environment to steer the user around. And so the next question that I'm working on is how much to steer the user. So for redirected walking, it's based on the user's perception, but everyone's perception is a little bit different. And so some users will be more or less sensitive to redirection. And it's important to know how sensitive a user is to this redirection so that we can deliver a good redirection experience or locomotion experience for the user. Because some users may tolerate more redirection than others. And it's important for us to be able to measure this. And lots of work has shown, not just this work that I show here, which is something we did a while back, but lots of work has shown that thresholds for redirected walking, so the limits of how much we can steer users, it varies a lot depending on a lot of different factors like walking speed or the FOV of the HMD, and the gender of the user, and also or like cognitive load and all sorts of things. And so it really is important that we can measure thresholds accurately for a variety of different situations, because it's clearer now that these thresholds do change a lot. So we do need to have a way to know what the thresholds are for any given situation. And so the goal with this part of my work is to estimate thresholds for redirected walking, both accurately and quickly for a variety of users. Quickly, because typical methods for measuring thresholds take very long, like on the order of hours. And it's not really feasible if we want, for example, redirected walking to work for consumers. Nobody wants to set up an hour-long configuration such setting. And so I'm looking into things like confidence ratings and Bayesian methods and for better curve fitting strategies. And then also I'm looking into physiological signals. So things like eye tracking data or posture data, and probably also machine learning, though I haven't gotten there yet, because it's just a curve fitting problem at the end of the day. So it seems very apt for this problem. This part of my work has less progress right now because we were limited due to COVID, but this is what I'm planning moving forward and what I'm doing right now. That's actually it for me. If you have any questions, I'm happy to take them now, and thank you for your attention.
Great, thank you, Niall. Thank you so much. Great presentation. I already see people clapping, and I see Dr. Scarbuz's hand is up. So already have a question.
Yes, thank you. Very interesting talk, very compelling results. And I'd actually like to comment on your most recent prototype that you showed on slide 16. I think that could potentially solve, I know you said that you don't envision showing the visualization to users, but I actually think that it would be potentially very helpful to show this visualization to users to solve a different problem with redirected walking than the sort of mathematical problem that you're tackling, which is the issue of how much do you trust the system to redirect you effectively, right? Because, for example, I know that I'm in my living room. I'm not going to walk at a normal pace because I don't trust the system to steer me away from my physical TV, right? But if I'm seeing a visualization that says this is the safe space to be in, that might actually resolve that problem and enable me to walk more naturally in the virtual environment than I would without the visualization. So yeah, I just think that that's really compelling, and I would be interested to see someone, perhaps not you, investigate the issue of trust. You know, how realistic is the walking motion associated with or the walking behavior associated with redirected walking. Really nice.
Yeah, thank you. I think that's a good question or a thing to investigate. It probably depends a lot on how they visualize the space as well, so that it's not intrusive. Thank you.
Excellent point. And we have another question, Dr. Solman.
Hello, thanks a lot. That was very interesting, very cool work. I really like this kind of aspect about being in the wild. But I assume it's a bit challenging to actually, fully prove that the system is working in the wild. So, do you have already any plans how to actually do this on a large scale, or actually, running it in the wild?
Yeah, we don't have many concrete plans at the moment, aside from. I guess the plan at the moment is get as many participants as we can and try to get IRB approval to do this in as many places on campus or around campus as we can.
Wow.
I think it's really just a matter at this point of getting as much data as we can in the wild. I'm not sure if there's like a systematic way to get the most useful data from the wild. There might be, but at this point, there's kind of nothing in this space on this direction. So I think at this point, the first step would just be getting as much data as we can in anywhere that we're allowed to, basically.
It's pretty cool. Thanks a lot.
Yeah, thank you.
Thank you. We have a question from Rui and a question from Dr. Thomas, and then we will take our break. So Rui?
Very quickly, cool work. What will you do when the system cannot match, when there's like no possibility of matching the real world with the virtual world? Do you have a fail-safe thing talked about?
So at the moment, what we would do is just try to steer the user the best we can, which would depend, I guess, on the specifics of the algorithm, and that would eventually, if the environments are really incompatible, that would just lead to the user walking towards an object in the physical space. And in that case, we'd have to resort back to the typical fail-safe for redirected walking, which is like initiating a reset. So have the user stop walking and then turn around in place until they're reoriented away from the object. I'm honestly not really sure if there's much we can do to avoid that. I think resets will happen regardless.
Vignetting and maybe move the person with some, like close the angle and go there, something like that.
Yeah, it's not ideal, but I think it's unavoidable, basically. At least I haven't thought of any ideas of any ways to avoid that yet.
Thank you. And Dr. Thomas put his hand down.
Yeah, no, I just put it down. Yeah, no.
Okay.
Awesome. I love this, and I think we all do, because I know I fear smashing my television when I use VR in my home. Just an idea. This is inspired by something I saw at UNC when they made these massive hallways with foam blocks.
Yep.
So you could get a reasonable space, and then you just make it. And the advantage of that is it's just a lot safer.
Yeah, that is something we're looking into. There might be like a basketball court on campus that we can use. So we have to look into it though. But yeah, it's something on the radar. Thank you though.
Yeah, no. Thank you for solving a huge problem.
Maybe I'll try.
Awesome, outstanding. Thank you, Niall, and thank you, mentors. We are taking a 15-minute break, and then we will be back with our next set of presentations.
Welcome back, everyone. It's 3 in my mountain time. We had excellent presentation and feedback in the first session. We'll continue that. So our first presenter for the second session is, sorry if I butcher her name, Montserrat Olsa-Baiken, and the mentors are Dr. Bruchala and Dr. Rob.
Yep, Montserrat Laushimkan.
Awesome, thank you.
All right, so hi everyone, my name is Montserrat and I'm currently a PhD candidate in computer science at Tufts University. And my thesis title is Designing Immersive Tools for Supporting Cognition in Remote Scientific Collaboration. So when the COVID-19 pandemic hit, we saw a huge shift to remote work and by extension, remote collaboration. For most of us, collaboration is a part of our daily lives. Scientists have been and continue to collaborate remotely across institutions, countries, and continents. However, collaborating remotely is challenging. Alston and Alston described several challenges remote collaboration poses to a team, including awareness of colleagues and their context, establishing trust is difficult, and there is a lack of motivating sense of presence with others. Research in remote scientific collaboration has explored the use of audio and video conferencing to make collaboration across distances easier and more productive. However, video conferencing tools used for meetings limit the kind of cognitive offloading that can be done to reduce mental load compared to a co-located group meeting with access to physical whiteboards, sticky notes, notebooks, and space. In VR, scientists can more readily engage in spatial and embodied interactions to absorb complicated material and collaborate to develop new insights. So I hypothesize that VR provides affordances for supporting cognition that video conferencing does not or cannot provide, and thus more research is needed to examine how to leverage these features and affordances available in VR to enhance cognition in remote scientific collaboration. So as the first study of my thesis, I conducted a qualitative study to identify the needs of scientists collaborating remotely in VR. So for this, we observed 2 interdisciplinary groups of scientists who were regularly meeting remotely on a weekly basis to collaborate on an NSF-funded project on coral reef data. So this included professors, graduate students, and postdocs whose research areas spanned biology, computer science, and mathematics. So the groups met in Spatial over a period of 4 weeks to discuss their research using images, sticky notes, PDFs, and 3D models. One group also used Nanome for exploring biological data. So we recorded the group's interactions during the meeting and had participants complete a survey and interview to gain insight into their experiences with meeting in VR. We then conducted a thematic analysis to identify themes. From our analysis, we identified several data and meeting organization strategies used by the scientists. And additionally, we identified several ways VR provides cognitive support to scientists, including providing them with increased focus and engagement, increased presence, data exploration autonomy, spatial arrangement, and physical manipulation. We also identified several limitations expressed by the scientists where future tools could be improved, including a steep learning curve, limited whiteboard and note-taking functionality, a lack of nonverbal cues and communication challenges, as well as friction with creation tools. One major limitation expressed by the top scientists centered around note-taking and communication. So the scientists in our study wanted to be able to communicate with others through both public and private channels and felt frustrated with the inability to write personal notes or quickly write down thoughts as is often done with pen and paper or a physical keyboard. So this led me to investigate ways we could improve note-taking in VR. So commercial VR applications that implement note-taking have used a variety of input methods. In Horizon's workrooms, users use their physical keyboard to type notes by streaming their desktop into VR. In Spatial, users write on sticky notes, which are visible to everyone in the room using a virtual keyboard or speech-to-text. And then research has explored using ray castings to write letters for text entry and tablet and stylus tracking for writing longhand notes. However, such methods have several limitations. Virtual keyboards are slow to use. Physical keyboards require being seated at a desk or wearing extra gear to hold a keyboard. Speech-to-text is error-prone, requiring extra cognitive load to correct mistakes, and using extra peripherals can be cumbersome. So to overcome some of these challenges, I proposed the concept of embodied notes, a cognitive support tool designed to enable users to make multimodal notes in VR, using a predefined set of gestures without extra peripherals beyond their headset and controllers. So the notes are represented as thought bubbles or spheres, where the outer texture of the sphere represents the visual context of where the note was taken. So users can grab a note from their pocket and bring it up to their mouth like a microphone to start recording their thoughts. They can then replay the note using a shaking gesture and delete the note by throwing it away. And these notes are private by default, but shareable with others. And I have a short demo video. The following concept video demonstrates the features of embodied notes, a multimodal note-taking system in VR. So with this prototype, I would like to seek to understand the role embodiment plays in note-taking for learning in VR. And so for my second study, I plan to conduct a comparative evaluation of the different design elements in embodied notes. So more specifically, I'll be conducting 2 sub-studies, one on interaction techniques and another on note storage techniques to investigate how these techniques affect cognition in tests of accuracy, comprehension, and memory. Each study I'm planning to do will be between subjects design, and I plan to recruit 30 participants for a total of 60 participants, and each participant will be placed in one of 3 conditions and complete 2 tasks, which I'll explain in more detail. So the 3 interaction techniques I will be comparing include controller gestures, where interactions with notes are primarily gesture-based, as depicted in the video earlier. For example, a user plays a note by grabbing it and shaking it. The second technique is controller buttons, where interactions with notes are primarily button-based. So a user plays a note by grabbing it and pressing the trigger button. And the last technique is controller raycasting, where interactions with notes are primarily through a menu and raycasting. The storage technique conditions include a menu that users add notes to using raycasting, a notebook with predefined spaces that users directly place notes into using their virtual hands, and a magnetic surface that users can place notes onto in any arrangement they'd like. The menu and magnetic surface storage techniques were adapted from the paper, A Taxonomy of Inventory Systems for Virtual Reality Games. So the 2 tasks we plan to have participants complete using embodied notes are watching a video lecture on the science of coral reefs and completing tasks at different stations in a virtual lab environment related to corals. At the end of the 2 tasks, participants will be asked to answer questions about the content they learned to measure their cognitive performance. And then for my final study, I plan to observe scientists use an improved version of embodied notes based on the results of study 2 in a collaborative VR meeting. In this study, the research questions I'm looking to answer are: how does embodied notes support cognition during a scientific collaboration meeting in VR? How do visual indicators of note-taking affect collaborative discussions and group dynamics? And how can an artifact state be recorded or saved for continuity, reproducibility, and sharing? So based on these 3 studies, the contributions of my thesis would be a richer empirical understanding of how scientists use virtual environments for collaboration, the design, development, and evaluation of the system embodied notes, a better understanding of the role embodied in spatial interaction in supporting cognition in VR, and design requirements for developing cognitive support tools for remote scientific collaboration. So the areas I would like feedback on are how I can improve the design of embodied notes. Are there additional theories that could help me further ground my work? And are there certain quantitative measures or experiments I should consider? I would like to thank my advisor, Dr. Leonard Cowan and Dr. Richier for advising me, and the NSF, Tufts Disc, and SIG-HPs for funding my research.
Thank you. Excellent work. Do you have any questions? Yes, Dr. Solman. Sorry, it was a clap, I guess. I'm sorry. Dr. Thomas.
Thank you. Very, very interesting. I was wondering, this is for your second, or basically the design of it. Have you thought about placing the notes in other relations to the body? I'm thinking the classic work by Marc Manet, where he actually had stuff floating above the head, or or a tool.
Oh, I see. So where you store the notes, or like where you retrieve them? Because we have the hands, like pockets near your hands. And then I was also thinking maybe like in front of you, as like you kind of look down. Is that what you mean? Is that what you're referring to?
Yeah, I think part of the embodiment is the fact that you can, through proprioception directly access them, but they're out of your field of view all the time. So if you could look to the, like if I'm looking to my right, sorry, and there's a palette there, and I can just grab them. So it's a head gesture more than a hand gesture to bring them up. Have you thought about something like that?
No, I haven't, but I think that definitely is something that I should actually consider.
Okay, I should also point out that putting stuff above the head actually really does hurt the neck when you keep looking up, but that's a different.
Yes, and probably not above the head.
I don't like it, but that's just me. Thank you very much.
Thank you.
Questions? We move to our next presenter. Our next presenter is Andrew Maxim, and the mentors are Dr. Rob and Dr. Scarvis.
I'm not sure which screen you're seeing. Okay. So I'm Andrew Maxim. I'm a PhD student in human-centered computing at the University of Florida, working under the direction of Dr. Benjamin Locke. As the title suggests here, the area of research I'm proposing for my PhD is improving the presence of virtual humans through paralinguistics. So in order to talk about my proposed area of research, I should begin by talking about presence. In computer science, presence is usually separated into three different areas: telepresence, social presence, and co-presence. So these three areas differ from one another based on the center of focus in what I like to call me, we, and you. Telepresence or spatial presence is the me portion, the feeling that I am transported to another place, I am there. As an example, a surgeon performing remote surgery should feel a high level of telepresence. We want that surgeon to feel transported to the operating room. Social presence is the we portion, the connection with other people, even though we are physically apart. We are there. In this era of COVID, we should all be aware of the importance of social presence as we connect with our peers and colleagues over computer screens, such as this, for our daily meetings, classes, and seminars. Co-presence is the you portion, the feeling that another person is present. You are here. A common example of co-presence can be seen in many online games where we view our friend's avatar as that friend. They are present with us in whatever world the game sets us down in. There's a lot of interaction between each of these, especially when discussing virtual reality. Ultimately, each contribute to the plausibility of an interaction, the level at which a person believes the interaction to be occurring, to exist in their current reality. For my research, I'll be focusing primarily on social presence, and particularly using social presence to maintain plausibility. So the computer industry and academia has spent more than a bit of money on improving computer graphics for virtual reality simulations. Whether it's the physical development of graphics cards so powerful they are now the de facto standard for running complex machine learning algorithms, or for virtual development of visuals so lifelike we can't help but stare in awe. The visual side of virtual reality has gotten a lot of time, money, and attention thrown its way. With this technology, we can present a virtual character to a person so lifelike in appearance, they would swear they're looking at another human. That is, until the virtual character or virtual human opens their mouth and starts to speak.
Hello, I am a virtual human.
Robotic, monotone, lifeless. Plausibility has been broken. To combat this, both researchers and the gaming industry use human voice actors to provide the voice for these virtual humans in pre-recorded snippets. This limits virtual humans in many ways. So the most obvious limitation of using pre-recorded voices is that it creates completely scripted dialogue between the virtual human and the human. Repeated responses can become stale and detract from the social presence. There's only so many times one can hear about how a character took an arrow to the knee before it becomes a meme. There is also the added time and financial expense of hiring voice actors. This can cause major delays in changing or adding dialogue, especially if the previous voice actor is not available. Lastly, in the area I find most important, pre-recorded voices don't have the option of adapting to the human they're speaking with. Our voices will often change and adapt based on the person we're speaking with, their mood, their energy level, and even their own vocal characteristics change how our own voice sounds. This piece of social presence is missing entirely when we use pre-recorded voices. By using computer-generated voices, we can reduce or eliminate these problems with virtual human interactions. So paralinguistics covers the range of nonverbal communication aspects that we use as humans, from facial gestures to raising the volume of one's voice for emphasis. For the purposes of my research, I intend to focus on the vocal characteristics of speech that will allow a virtual human to feed into human perceptions and convey that speech in different ways to different people. Computer-generated voices have come a long way in the days since Joshua speaking in the movie War Games, and I don't believe they need to sound robotic or monotone any longer. Through advances in technology such as speech synthesis markup language, or SSML, we can manually or procedurally alter the characteristics of computer-generated voices in such ways as pitch, rate of speech, or volume. This can be done granularly down to the individual words in order to provide the proper emphasis for the message being spoken, or to create a better rhythm of speech that is less apt to break plausibility. During phase 1 of my proposed research, I've hired 3 voice actors to record 14 different neutrally rated statements. Each voice actor recorded 3 different versions of the statement, one using a confident voice, one using their natural voice, and one with a soothing voice. Two such voices have been tied to the virtual human, Alex, shown here.
Hello, my name is Alex. Hello, my name is Alex.
So I will have participants rate each of these 9 voices on perceived trust and expertise using randomly assigned statements. I will analyze the vocal characteristics of the top rated voices to determine the average pitch and rate of speech, as well as any specific pauses or changes in volume. For phase 2 of my research, I plan to replicate the vocal characteristics from the top voices in phase 1 using computer-generated speech. The computer-generated speech will use the same 14 neutral statements from phase 1 and be attached to the same virtual human. Participants will rate these new voices on trust and expertise as well. For phase 3, the top-rated computer voice or voices will be used to create the voice for a virtual human that will provide information on colorectal cancer screening. Participants will be asked to rate their intention to be screened for colorectal cancer during pre- and post-intervention surveys. Participants will also be asked to rate the trust, expertise, and social presence for the virtual human. So while I have a few specific questions listed here, as far as for Consortium, I am really looking for ways to better scope the focus of my research into paralinguistics and virtual humans. So with that in mind, which vocal characteristics should be the focus in terms of which audiences? How much human voice data should be collected for use in computer-generated voices? How focused or broad should I make the scope of my research? And are there specific avenues I should consider for paralinguistics? So I'd also like to acknowledge that funding for my research is supported by the National Cancer Institute of NIH under a T32 award. And my references, and thank you. I will take any questions, comments, or suggestions.
Thank you. Excellent work. Do we have any questions? Any questions, suggestion?
This is Alicia. I have a question. Oh, I see. Dr. Rob has a question also. My question is, have you thought about the metrics that you're going to use to evaluate their sense of social presence?
I'm not going to evaluate social presence until the end, and it'll actually just be through a survey question to determine their feeling that the character was real and was present with them.
And I guess along those lines, you're looking at behavior change too, right?
Ultimately, yes.
So what are you associating that behavior change with? You're associating it with social presence, I assume, or something else in addition to that, or?
That behavior change mostly in social presence and plausibility, but there's also comes into a lot of play of user preferences and things like that. This is kind of part of an ongoing research in colorectal cancer screenings. So.
And my last question in that domain, are you also looking at user experience ratings?
I was not, but I may be now.
Awesome. Thank you. Very interesting. I hope to stay in touch. It's really cool stuff you're doing.
Thank you. Dr. Rob?
Thanks, Andrew. Great talk. And I'm looking forward to getting to speak with you later today. The first thing I was thinking of is a lot of the paralinguistic measures you were describing in your introduction involve interaction between two people. And so you mentioned, say, like voice adaptation. So we adapt our pitch based on the pitch of the other user or the other person involved in the conversation. Are you planning to have an interactive element like that in the third phase, where they actually talk with the virtual agents?
Not in the third phase of this study. I would like to, however, perform future studies where it is dialogue based, back and forth, where I can test that adaptation. But for this particular study, no.
Okay, great. Well, I'm looking forward to talking with you more later.
Great, thank you very much.
All right, thank you very much. So moving forward, our next presenter is Yu Zhao, and the mentors are Dr. Feiner and Dr. Thomas.
So, can you see my screen properly?
Yeah.
Okay. Let me introduce myself again. I'm Yuzhao from Vanderbilt University. You can call me Brooke. At first, let's imagine the glasses I wear are a future lightweight air display. We wear them all day, walk around, and we want to navigate in the city using these air glasses. So how should we design the air glasses to aid navigation? My dissertation aimed to help answer this question with the displays we have available right now. I'll discuss my nascent plan in today's talk. Wayfinding is a task that we conduct every day. As we navigate, we perceive surrounding spaces and form a mental map from different spatial perspectives. This mental map supports efficient route finding and permits adaptive novel shortcuts. In recent years, human navigation has dramatically changed with the use of assistive navigation systems. These navigation aids greatly help people navigate to their destinations. However, we gain these benefits at the cost of spatial cognitive descaling. Extensive research has shown that the navigation system utilization, especially turn-by-turn instructions, impairs spatial learning and memory in short and long term. The progress in AR head-mount displays foreshadow the prevalence of such devices as computational platforms of the future. It opens a new design space by integrating synthetic graphics into users' task space, and has been demonstrated has lots of potentials for navigation tasks. Even so, before AR becomes widespread, it's important to better understand how design elements interact with user perception, behavior, and cognitive process. For example, how the new design space affects spatial information processing, and if with careful design, it could help with navigation efficiency with no cost of spatial learning. Currently, most AR navigation usability research have related to vehicle driving. There is a significant opportunity for pedestrian navigation studies. Walking scenario with more self-locomotion includes more body-based cues and requires a different level of cognitive load compared to driving scenario. So the questions may become entangled and demand more considerations for the effects of design decisions on pedestrians. So in this research agenda, I plan to develop and evaluate a novel pedestrian navigation system paradigm for AR HMBs that considers not only common usability issues, but also spatial learning. I aim to inform a learning-aware AR designs that can augment spatial cognitive abilities in users that interact with such AR systems. My first questions are what the essential navigation information to display and how to show them in AR HMBs. Directional information like we currently used in consumer turn-by-turn navigation systems is a significant component in navigation completion. Besides, studies in psychology and cartography suggest that landmarks are the most predominantly used spatial cue for self-localization, orientation, and forming mental map when they're available. So for the types of information to display, I consider both directional and landmark information. Then where to place and how to manage the content in AR HMBs. Follow research in automobile AR, the design space for AR can be categorized into screen fixed and word fixed design. Screen fixed design present visuals in a constant position relative to user's head. Word fixed design present visuals that are registered to the physical world. Recent research indicates that word fixed designs are not superior compared to screen fixed design. So I propose a 2x2 experimental design varying the factors of design view and information type to explore the interaction between the two factors in pedestrian AR navigation systems and how they affect people's navigation performance, cognitive load, viewer attention, and spatial knowledge acquisition. I predict that people experience better navigation performance gains by using word fixed cues, and adding landmark information benefits spatial learning. On top of that, if the word fixed design with added landmark cues benefit wayfinding and spatial learning, my next question is how to effectively utilize the three-dimensional word space and design the word register landmark AR cues. Compared to local landmarks, global landmarks visible from many locations in an environment are helpful for orientation and acquiring spatial knowledge because they provide a very accessible spatial reference frame, and memory for global landmark configurations is more accurate. Besides, it should be noted that people differ in their abilities to make use of various sources of spatial cues. Some may benefit more from the digital cues and some may not. So it's important to think about our design decisions based on individual differences. So I propose visualizing the occluded landmarks along the navigation routes as virtual global landmarks by air graphics for allowing users make use of them for reorientation and acquiring spatial knowledge. And I also would like to see how people with different spatial abilities benefit from the new interface design. Furthermore, when in the future AR becomes omnipresent in our environment, the displayed content may occlude real-world objects and reduce users' situational awareness on their real-world tasks. Accordingly, a significant question is how to efficiently convey navigation information in an understandable but non-intrusive manner. Therefore, I intend to manipulate the visualization complexity of these virtual global landmarks to see the extent to which different individuals utilize them for recalling spatial knowledge. The approach I'm going to use is a mixed reality simulation. I plan to investigate the AR navigation interface design by simulating AR systems in virtual reality. I think this benefits us in two perspectives. First, it confronts participants with unknown environments for assessing spatial knowledge acquisition. And second, it may better simulate a future AR headset with more advanced specifications like a larger field of view. For evaluation, I will apply what I find in VR to AR HMDs. I plan to use a HoloLens 2 to see the usability of the design outdoors as my third research question. This also contributes to evaluate whether and how AR can be used as a safe and cost-effective test bed to rapidly prototype and assess AR designs. I'm currently working on prototyping an AR navigation interface by transmitting GNSS and MU data into HoloLens for large-scale outdoor usage. Finally, I hope to receive your advices on considerations for efficient AR simulation in VR to inform the design of future AR platforms and some other design parameters that might benefit pedestrians. And thank you for listening.
Excellent work. So time for questions, suggestions, and feedback. So we have Dr. Orlowski.
Hey, yes, thanks for the talk. This is really great. I like this space. So one question regarding the screen fixed and world fixed annotations, augmentations. Are you by chance considering hybrids of those? So for example, let's say horizon stabilized or annotations that just face the target but travel with the display?
Yeah. I propose screen fixed and world fixed. It's just from the categorization from the vehicle automobile AR, but in the pedestrian scenario, it might be different. It's not strictly screen fixed because your walking direction may be different from your hand movement or your looking direction. So it might be not strictly screen fixed, but just fixed to maybe part of user's body to better indicate the direction or give a, yeah.
Very good. Thanks.
Thank you.
Yeah, this is really interesting. It reminds me of some of the work I did in my dissertation, and I don't know if you've found that. I think there might be some findings in that might help about how to look at some metrics and some design ideas to really promote the configurational knowledge, which I think is what you're trying to develop in your users. I was wondering, you talked about some metrics for navigation performance, and I was wondering what kind of metrics are you looking at for that? And then also what kind of metrics you might be using for the spatial cognition?
So
or
for
the configurational knowledge, I mean.
Yeah, for the navigation performance, I think the accuracy, like whether people make a correct turn and the decision point and the time they complete the navigation task, is definitely the metrics I'm going to use. And maybe I will also record the trajectory when people navigate in the road to see whether they have kind of pause in specific point and the roads and things like that. Of course, yeah.
Are you going to have the users, are they plotting their own paths, or are they getting turn-by-turn guidance from your system?
Currently, I'm thinking turn-by-turn guidance.
Okay, yeah. I guess I've been disappointed by some of the other research in the way that, looking at navigation performance, because you're trying to uncover sort of the mental workload about making decisions, and that usually gets swamped by, the navigation time, and then, you're just trying to recognize whether you're turning during the turn-by-turn. So I sometimes I worry that there's not much there, and that's not really informing the design very well, but I could be wrong.
Yeah, this is we actually thinking how to assess the cognitive load. One is just by the questionnaire, like just the NASA TLX, like we all know, and another way we think about is use a detection response task, which is a secondary task when people actually navigate in the road. But
yeah,
they have.
I wonder if there's some emotional methods, like confidence that the user feels as they're navigating. I don't know, but I don't want to take up too much time. But really interesting. And how were you going to look at the other metrics?
You mean for the spatial learning?
Yes.
Yep. So we consider the survey knowledge for assessing the spatial knowledge. Survey knowledge means how people form their cognitive map in terms of directional and distance metrics, like the relative direction between two landmarks and relative distance between two specific landmarks.
Okay, thank you.
Yeah, thank you.
A quick question from Dr. Scarvas.
Yes, I'll try to be brief. Thank you very much for your talk, Brooke. I really enjoyed it. My question is, you're talking about a system that's going to help develop spatial learning, help develop a cognitive map of the environment, essentially. Are you intending to develop the spatial learning with AR or after you take off the AR? Because that would imply sort of a different design for your global landmarks, right? Because in one case, you could create your own global landmarks, but they don't exist after you take the AR off. So you may be developing sort of a false spatial knowledge about the environment. And in the other case, it might suggest that you want to identify good global features that already exist in the environment and highlight them in such a way that people pay more attention to them. Just wondering if you've thought about that or what your plans are.
Yeah, currently my plans is for just highlighting in some way that already exist in the environment. But yes, of course, if we envision in the future, there are lots of virtual objects in our environment, they may be considered as kind of landmark. Yeah, this is another opportunity to explore and investigate how people utilize them for spatial orientation.
Awesome, thank you. With respect to time, we have to move. Thank you very much for the talk. So our next presenter is Zara Bohani, and the mentors are Dr. Orlasky and Dr. Bowman.
So I assume you are seeing my slides, right?
Yep.
Okay, great. So hi everyone, I'm Zara. I'm a PhD student at Colorado State University, and the topic of my DC is annotation in asynchronous, collaborative, immersive analytics environment using augmented reality. Augmented reality is a technology that merges virtual objects into a real world. And immersive analytics is a new term referring to the use of immersive technologies such as augmented reality or virtual reality for data analysis. And finally, asynchronous collaboration means multi-user can work on a task at different times. So there is no need to work in real time. Before emerging immersive technologies, the only option for data visualization initially was paper and pen, and then later 2D displays with their associated inputs such as digital pen, keyboard, mouse, or display touch. But nowadays, immersive analytics and augmented reality head-mounted displays such as HoloLens provide a paradigm for users to explore and interact with 3D data visualizations in an immersive environment. So here is a short demo of the environment of our system. As you can see, user can interact with the 3D scatter plots using hands-free gestures. They can filter some of the annotation to avoid cluttering scenes. As you can see, there are different types of annotation. Let's play the audio one. If you look at the first plot, we can see the quality is a... Now play the video. Okay, so our area of interest sits in the intersection of these three domains: annotation, which can be in augmented reality or 2D or 3D scenes, immersive analytics, and collaborative augmented reality or virtual reality. Here are some of the previous studies that motivated our work. In the context of immersive analytics, there is a work by Lee et al. They explored data visualizations in a symmetrical, synchronized, collaborative environment. They used annotation in their system. However, they did not, their main focus was not annotation. They used their system in virtual reality. In another study by Fonet et al., they surveyed 177 papers in the context of immersive analytics. They found only 8 papers used annotations or highlighting in their system. When it comes to annotation or data visualization, papers in 2D are a valuable resource. So here is a work with Kim et al. They investigated how people externalize their thoughts during data analysis. They found that people prefer to use and generate graphical annotations and not textual annotation. They also had some observation on what were the annotation that people created. For example, they were about correlation or, for example, plots names. Another study by Renet et al. Introduced Chart Ascent, which is a web-based annotation application for data analysis. They use data-driven storytelling. We have the work by Garcia et al., which used a handheld augmented reality in a asynchronized collaboration. So the users can use annotation to guide other user. They can create image node, hand drawing, and 3D models annotation, and then later in a different time, another user can review these annotations. So to have a better understanding of the annotations, we surveyed a total of 80 papers from different venues and in annotation in AR VR. We found that 29 papers out of these 85 papers were collaborative. And if you look at the bar plots below, most of the papers used remote synchronized asymmetrical system in their work. And as you can see, very limited number of studies investigated asynchronous collaboration. And to the best of our knowledge, all of the previous immersive analytic studies have focused on synchronized collaboration. While if we really think and believe that immersive analytics will be used in future in daily works, asynchronous collaboration is an inseparable part of it. So we define and classified annotation based on the papers that we reviewed. And we classified the annotation into based on their format, their creation method, the target, and the annotation dimensions. So in the bar plot, you can see the distribution of the papers based on their annotation forms. As you can see, most of the systems use textual, 2D or 3D models, hand drawing annotations, images, highlighting, video, and audio annotations. So we consider text annotation, 2D and 3D models, drawn lines, images, audio, video, and both free-form and predefined annotation. We consider word-fixed annotation, which means annotation are anchored to a specific location in the word or a specific target. And here you can see some of the most common annotation that were used, which were for labels and notes for textual annotation, and arrows, circles, direct lines, and cubes for 2D and 3D models that we used for our models. Okay, so our research includes a series of studies aimed at exploring 3D data visualization in a synchronized collaboration setup. In the first study, we compared different forms of annotations to find out which form of annotation are favored more by the viewer. In the second study, we want to understand how people think and what are their priority in a cluttered scene. So people can use filtering technique to filter some of the annotations. They can filter annotations based on annotation forms, confidence degree of annotator, and the number of plots. And so here you can see if a user wants to filter annotation based on the annotator, they can filter it. And then in the third study, we want to explore data-driven annotation technique. And in this study, actually users must to allocate the generated annotations to a specific target, for example, data items or coordinate spaces or prior annotations. And finally, in the fourth study, we want to investigate the effect of storytelling annotation on user understanding. So user creates annotation similar to the previous one, but in this time, they need to assign an order to the annotation. So later in viewer mode, these generated annotation will be displayed in a specific order to actually tell a story. And here are some questions that I would like to get feedback on. First, is there any other annotation technique in 2D that I should consider? Should I compare the experiment with the 2D web-based version? Has an important metric been overlooked? And do you have any recommendation to improve this work? What other research questions can be answered by similar experiments using this system? Thank you very much for listening.
Awesome, excellent work. So time for some questions, feedback. Any questions, any feedback? See a lot of clapping. Okay, so we have one question from Dr. Olarsky.
Hey, yes, thanks for the talk, and I'll be talking to you afterwards as well. Really great plan for the different types of studies. do you have any particular target applications within analysis? So for example, education or like work-based applications, navigation that you'd like to explore?
Yeah, I think education would be a very good application for it. But on the other hand, I think it might be even be used in a more advanced level for data visualizations. Yeah, both of them actually.
Okay, and then yeah, a quick follow-up to that. Do you plan, let's say for education, would you recruit like high school students or college students or like people in industry?
Yeah, for my experiments or in general? For my experiments, I think since it is a little, we actually had a pilot study and I saw that it is a little hard to answer some of the questions even for college students. So that's why I'm not going to consider high school students. Maybe they are good, but I don't know. I just don't want to risk since it is hard to find participants in COVID-19. So I'm going to consider college students, and actually there will be a survey to ask some questions about their knowledge about immersive analytics and data visualization to make sure they know actually what is going on.
Okay, great. Yeah, I'll talk to you afterwards. Thanks.
Sure.
Dr. Scarves.
Yes, thank you, Zara, for the presentation. And I apologize if you covered this. Maybe I just didn't understand it clearly. Are you going to have participants working in teams, in dyads or teams to solve analytic problems, or are you going to have it where, say, the annotator is a confederate or you are the annotator and they are just expected to interpret the data that the annotator has added to the visualization?
Yeah, actually, that's a good question, and I did not explain it since there was no time, but there are different types of studies. In some of them, for example, in the first and second study, I'm going to pretend, and I also use some of my friends and collaborators to generate annotation for the first and second study that are exploring the viewer mode, and but in the third and fourth study, there will not be an actor as the collaborator. There will be actual people who work, but in asynchronized time.
And I guess a follow-up, sorry, I'll try to be quick. Are you going to have sort of a metric of success for the collaboration? So, and if not, I would encourage you to think about that, such that, you know, are they actually trying to solve a problem and they need to get within epsilon of the right answer in order to, you know, be counted as having had a successful collaboration?
Yeah, exactly. What I'm going to do is in the third study, actually, I'm going to ask participants to annotate the system to help their collaborator to understand a specific question. So, and then later we will measure the correctness of the answer and also how they understand their performance, the time that they could perform the task, and all of these measurements. If there is any measurement, I would be happy to realize, because it is a hard thing to measure, actually.
So we can have a last question, I guess, a quick question from Dr. Ru.
Quick. So are you just thinking about about simple annotations, or could it be possible for like a team, like one person does one exploration of data and saves that exploration for later, and later someone sees how someone got to a specific part of the data, like with an animation or something, and accepts the exploration or rejects the exploration? Could you see something like that, or are you just focusing on putting some sticker notes next to it?
Sorry, please correct me if I'm wrong, but you're mentioning if the users will see their the collaborators can reject some of the annotations that are created with their collaborator.
It can review and reject in a synchronous time.
Oh, no, I don't have plan maybe later, but in the studies that I explained, they are not synchronized.
Okay.
Thank you very
but
much.
It's very interesting, and I'm going to actually continue that. Yeah, thank you very much.
Thank you. So moving forward, our next presenter is Zaidan Hu, Dr. Krum, and Dr. Orlesky is the mentor.
Okay, hello, my name is Xiaodan Hu from Nara Institute of Science and Technology, and my research is designing and optimizing a daily wear for the fog with smart sunglasses. Okay, first let me introduce myself. I received a master's degree at NICE and completed the initial architecture and algorithm implementation of smart sunglasses under the guidance of my supervisor, Kiyoshi Kiyokawa. I'm now a first-year PhD student and continuing my research on assistive smart sunglasses for photophobia based on my master research. And my research interests are visual augmentation and display. And by the way, I love to play treasure hunt games and was lucky to be the winner of both IEEE VR 2021 and ISMAR 2022 treasure hunt games. Thank you. And okay, back to my research. And my research is to develop assistive smart sunglasses for photophobia. And it's also called light sensitivity. And it's not a kind of disease, but a symptom associated with some neurologic conditions or eye diseases. So individuals with photophobia can be stimulated by the sunlight outdoors, but also the indoors lighting can make them uncomfortable and even painful. Photophobia may be triggered by light of different wavelengths or highlight intensity, but here we mainly focus on the highlight intensity. A typical example is autism spectrum disorder. Some individuals with autism spectrum disorders have been found to have abnormal pupil mechanisms like a longer pupillary light reflect latency and lower constriction velocity and smaller constriction amplitude. And this all result in a larger pupil size. So it is conceivable that their vision will be brighter. So most of them may wear dark or colored glasses in their daily life, which is effective to photophobia. However, wearing sunglasses for a long time can make the eyes dark adapted and is harmful to treatment. And the auto-dimming glasses with a light sensor are also a good choice, but they are not adapted in some complex environments like indoors or moving light sources. And in recent years, occlusion-capable AR display have been developed which can accurately dim a bright area in the user's vision. However, to achieve a precise occlusion effect, many optical components must be used, which makes the whole system high-costed and bulky, and cannot be a daily wear for photophobic people. Another similar application is the ADR camera. As you can see, there is a single spatial light modulator put in front of the camera to achieve a dynamic range imaging. However, their algorithm to achieve for controlling the spatial light modulator is based on the acquisition from the camera. So it appears impossible to obtain the image data from eyes in our system. So that means we need to design a specific control method for the spatial light modulator. We first designed a benchtop prototype to test and evaluate the system. The image intensity obtained by the same camera is is the input to modulation function and compute appropriate occlusion mask displayed on transmissive LCD. And the occlusion mask filter the incoming light so that the user can observe through the LCD with lower contrast. Because the structure is quite simple, we also designed in implementable various sunglasses. So you can see here is a mini sync camera behind the lens. And we designed the requirements for the modulation function. So first, high intensity regions are discernible and deemed for comfortable viewing. And second, low intensity regions are not deemed and kept nearly intact. And finally, the regions with higher or lower intensity appear brighter or darker after modulation. However, this structure design of a single layer LCD creates a serious problem. The occlusion mask displayed on the LCD become blurred due to out of focus, and thus cannot provide sufficient blocking. This out of focus process can be simulated by a convolution, where the size of the convolution kernel is approximately to the aperture radius. The previous works often expands the occlusion mask by the rate of the aperture radius, but it leads to another issue called occlusion leak. So as you can see on here, the occlusion mask calculated based on the aperture radius is extremely large. So it even broke the statue behind the snowman. Then I proposed an optimization model by stimulating a mask and assigning each pixel of the mask a weight representing the occlusion efficiency. So finally, we're able to get an optimal expansion rate. So here is the result of our optimal expansion rate. So for a better visualization, you can see here actually the background is black. I changed the background to a lighter color and keep the occlusion mask static. So you can see here, this is the result of the aperture-based algorithm. And with our method, we can see the statue behind the snowman very clearly. Here is the more detailed comparison. So as you can see, while the naive, the unproposed, processed occlusion mask cannot cover cannot cover the bright view sufficiently, and the aperture-based method shows a severe occlusion leak. And our method, you can see all the objects like the book, the snowman, and the and the statue in the shadow very clear. And currently, I'm working on the real-time system designs and preparing the user study. I adjust the rendering latency and ensure the system could react within 50 milliseconds. So the optimal mask expansion rate varies with real-time pupil size change. And I'm also want to explore whether there's some more suitable optimization or control method for the spatial light modulator, such as showing the convolved occlusion mask. Okay, and thank you for your attention. This is all my presentation.
Thank you very much. So time for questions and suggestion. Out of claps. Okay, Dr. Bobby.
Hi, that was a really interesting talk. So is it important that the that you occlude things over the entire field of view of the glasses or just in the foveal region?
You can say I just this is you can say this is the occlusion mask, and it actually a selective dimming, but actually the occlusion mask is calculated by field view, but like in here this is a black background, and so the occlusion mask is almost a white pixel here, so it's a kind of for occluding, I think.
No, but I guess for your problem, I mean, to be in an ideal situation, because glare and white light can come in from an angle, right? Bright light can come in from an angle. So I'm just wondering, from an ideal point of view, do you want the occlusion to be dimmed across the entire field of view of your glasses, or is it more important to dim it in the focus region of your eye, what we would call the foveal region of your eye? Do you understand my question?
Yes, I understand. Sorry. Yes, this is actually yes, this is our future work, because now yes, the objects are fixed. And with this real-time system designs, we also want to fix the objects. And after we confirm the effectivity of our system and our algorithm, we want to also develop a variable type that considering the head movement and the pupil rotation, the eyeball rotation. Yes.
Okay. Okay. All right. Thank you.
Thank you.
Dr. Orlowski.
Yeah, so this setup, awesome talk, and the setup reminds me of I think your advisor's Professor Kiyoshi's old setup when he was doing the
yes,
very reminiscent. So one quick question: so the camera that's used for scene detection here, is that an HDR imaging camera?
It's a kind of high dynamic because the color depth is 10 bit.
Okay, yeah. Good. And then so secondly, have you considered also applying some of these techniques to video see-through augmented reality, where you can completely control the light range?
Yes, the optical see-through. You mean?
Well, have you also thought about video see-through?
Oh, video see-through. Yes, the video see-through. So we want to build a daily use for people. So like a video see-through, a VR glasses is too bulky for a daily use, I think.
Okay, that may change in the near future. Maybe just consider for future work. And then one last small question. You mentioned some eye tracking.
Yes, right.
Or do you also plan to use pupillometry to determine how much light is being let in?
Yes, right. This is our current. This is my current progress here. Is we want to use an eye checker to detect the pupil diameter, so that I can set the optimal mask, the expansion rate.
Okay, great. Thank you.
Thank you very much.
Thank you very much. And our next presenter is Daniel Munoz, and the mentors are Dr. Scarves and Dr.
Can you hear me clearly?
Yep.
And see my screen?
Yes.
Let me try to hide this. Not sure if I can really hide this element. So, yeah. So hello everyone. I'm Daniel Munoz, and from the Hong Kong Polytechnic University, a PhD student, and I'm going to present my work, which is about virtual reality presence, and it's called the informational load of presence illusions on users' attention and memory. So virtual reality presence has been broadly discussed in the early 90s, and defined by scientific community as the sensation of being in a place while the body physically located in other. Within this work, we follow the definition of presence of Mel Slater, and that says presence is a psychological sense of being there when our body refers to the virtual environment instead of answering to the physical reality. So within the same school of thought, but in the other hand, immersion is also defined as a quality of the system technology that supports sensory contingencies and also a set of valid actions that are supported by the virtual reality systems. So we could say that system is immersive when it offers a high fidelity simulations through different multiple sensory modalities, but when it's also capable to map the user's physical actions in the virtual environment, and when it's also capable to move or transport participants from the external world to the virtual world. So according to the framework of Mel Slater, virtual reality presence can be divided and then two main dimensions. The first one is called place illusion, and the second one is called plausibility of illusion. Place illusion is actually the illusion to be in the virtual place, and plausibility of illusion is the illusion that the things are actually happening to the user and they are plausible. So when these two things are in combination, we will say that the people respond realistically to the stimuli of the virtual scenario. So more literature extending the framework of Mel Slater established a relationship between immersion and place illusion and introduced the concept of coherence and a relationship with plausibility of illusion. And they also introduced the relationship between coherence and as a characteristics of the scenario and immersion as characteristics of the system. So they say that actually, if we modify these characteristics, we could have a different, or we could alter a different perceptual or psychological answer of place illusion or plausibility of illusion, and also the overall levels of presence. So literature also shows presence influence factors in the case of immersion, such as field of view, haptics, spatial sound, frame rate, and synchronity of response, and others. And in the case of coherence, physical interactions of our virtual body, virtual humans, such as non-player characters, player characters, and also certain characteristics of the scenario. So if we modify them, we will have a different answer between place and plausibility of illusion, either according to where they belong, and also in the overall levels of presence. However, in presence and in current studies, we are having contradictory results. So, for example, higher levels of presence are related with higher levels of cognitive load. Higher levels of presence are also related with decrease on learning, different learning styles in some studies. And also higher levels of presence were negatively associated to memory, particularly in could recall in a study of Professor Valenson in Stanford. So we could say that the current literature could not explain in detail which dimensions of the construct of presence, either place or plausibility of illusion, is causing this overload or these internal distractions, and in which proportion these factors, place and plausibility of illusion, are operating. And in the meantime, presence factors, place of plausibility of illusion, have not been completely tested in terms of attention for the users and memory. So we believe that due our working memory capacity is limited, there's a divided attention phenomena working inside of the virtual reality experience. So we believe that the information that's built in present is actually creating somehow certain distractions and divided attention. We believe that this is happening within two situations. The first one is when we introduce something that we call inconsistencies. These inconsistencies could be unusual elements, unexpected elements or behaviors, or things that are outside the expectation of the user before going to the virtual reality environment. And we believe that these things are actually increasing the attention towards presence and distracting the people from towards the central task, or the task that is intended, or the experience that is intended in virtual reality. We believe that these things, these inconsistencies, are actually not a negative thing, but we believe they're actually a key for attention and presence in virtual reality. We also believe that when we introduce these inconsistencies, either from immersion or coherence, in a smart way or in a wise way related to the central task, it could also be a key for informational design on virtual reality. So we propose a study that main objective is actually to investigate the informational elements of these presence illusions and the impact in users' attention. And it has three main activities or three main objectives. The first one is to test the effects of place and plausibility of illusion towards attention. The second one is identify and quantify, but more than quantify, is provide certain proportion of these elements and provide a hierarchy of these elements according to their attentional impact in users. And also we wanted to provide certain guidelines for appropriate informational design according to the cognitive impact. So we have certain research questions, but we are curious mainly about two things. The first one is how these inconsistencies, either from immersion or coherence, these characteristics of the system or the scenario impacts user attention, if they impact differently, similarly, and what is their hierarchy, what is their proportion. And the other thing is how does the impact of attention of these inconsistencies presented in these different illusions affect the overall levels of presence. So we proposed two studies. The first one is related to immersion and place illusion, and the second one linked to coherence and plausibility of illusion. We are actually using the influence factors as condition of experiments, and for logistic reasons, we are conducting the study number 2 first, where we have actually 4 conditions. One is one per each characteristics of the scenario plus a control group, and for task 1 also per factor. And we are also conducting a secondary task using an MBAC test, using free recall after each of this task to understand the borderline between memory and attention. And before the stimuli, we're also conducting certain measurements of self-evaluation of memory systems to observe if there's mediation of memory on the participants. And after the stimuli, we are conducting certain measurements of presence, SUS, and the presence reality judgment questionnaire. And also we are conducting a task load index to see if our MBAC test is actually proper. So we're expecting or trying to aim to clarify, maybe make it more complex, we don't know, but may I try to clarify these effects of plausibility of illusion and plausible illusion towards attention. And we believe that explain these effects is actually contributes to design appropriate content, also avoid excessive informational and sensory stimuli, address distractions, that we believe that this is very important, address distractions and drive attention toward the experience intention of the virtual reality. And we also think that understanding the impact of these inconsistencies, either for coherence or immersion, could help in accuracy of informational design, retention, maybe absorption and transfer on virtual environment. So yeah, we're trying to extend the knowledge of this human sensory perception in simulated environments. And these are the reference of my presentation, and I will be happy to have some feedback and questions.
Work. Excellent. So do we have any questions? I see a lot of claps. Yeah.
Well, I'll go ahead, even though, Daniel, I think you did an excellent job with the presentation, even though I talked to you already and I'm going to talk to you again later, but I might as well raise a question in a public setting. So how have you thought about, or how will you respond to the idea that you may be sort of measuring attention twice, right? Because attention is its own thing, right? That this idea of measuring attention, but it's also many models of presence have sort of attention built into it. And I don't specifically remember whether that's in the reality judgment questionnaire or not. You might have to correct me, but you know, the relationship between attention as an input and attention as sort of an output of what you're measuring, what will that tell you about the role of attention in presence and the role of presence in attention?
All right, I see 2 questions in one. I think I understand 2 questions from one. But yeah, the first thing about, yeah, I will try to isolate the attention from the present questionnaire. So for particularly the present reality judgment has different dimensions. So the one we are observing then is actually the reality judgment. And I'm also only using that dimension of the questionnaire. I'm not using the other dimensions because we're interested in the reality judgment. And for the other reason, we have the MBAC test. So we're actually measuring from MBAC in terms of attention. And the second thing about attention, what it will tell us, I think what I want to know first is actually a proportion of the impact. I mean, all of these factors, either physical interaction, virtual humans, or what are their proportion of impacts towards attention. So at least I want to know what is the hierarchy or the proportion in their impact of the attentional lobe to see, okay, which is more strong at least, and which is the least strong, and which we should be more careful in terms of when we try to introduce it either on narrative or in gaming or in another type of experience of virtual reality. At least we will know the proportion. And then later, probably I will propose another study to maybe play with these inconsistencies all together, maybe in a line, all separately. Oh yeah, I think this is more or less the idea. Not sure if I answered your question.
All right, thank you very much. I guess so we are at the end of second session. We'll adjourn for our break. It's going to be 45 minutes break. We'll be back at 1:15 local time at New Zealand. So 45 minutes, approximately 45 minutes from now.
I was just going to add one thing for all of the DC participants who have the fortitude to stay on this whole time or come back. One of the things that we talked to our program officer about who funds the Doctoral Consortium was the loss of the banquet and how much we missed that. So the National Science Foundation program officer this one time has approved us distributing Uber Eats gift cards to the participants of the Doctoral Consortium, so we can try to do something that's kind of like simulating the banquet that we traditionally have had. So in the next 15 minutes, as I figure out how to send out my Qualtrics form, because I don't see a send button, I will share the link, and then I will send everyone who replies, who is part of this event, a $50 Uber Eats gift card. So we can try to simulate in our second break, for those of us who are still here, this experience of breaking bread with one another and just having informal conversation and, I don't know, talking about what we're eating and what we're thinking and how we're going to connect. And that will be in the chat shortly. I just have to figure that out. And then during the next session, while people are talking, I'll be sending gift cards as soon as possible so people can actually get food in time for the second break. And if you are in a time zone where you cannot get food, then you could just sit with us and use the gift card another time. So hopefully everyone can use Uber Eats in your area. It was the one we thought was most pervasive.
Thanks for doing that, Alicia. That's really awesome.
Thank you. It's been an interesting process, but thank you for thanking me. And I will see you guys soon. I'm gonna go dark and try to figure this all out.
Hi, everybody. Welcome back. I think we are ready to start session 3, and I will be your host, I guess, keeping the time. And so I think we're ready to go. Our first presenter is Matt Gottsacker. And Matt, the floor is yours.
Okay. Thank you. I will share my screen. I dropped my DC paper in the chat for anyone who is interested. Can you see that presentation screen?
Yes, we can.
Awesome. Okay, just doing some window management. Okay, so hi, I am Matt Gottsacker. I am a second-year PhD student at the University of Central Florida, advised by Professor Greg Welch. And this is my presentation on balancing realities by improving cross-reality interactions. So the motivation for this work is set in a, or is rather future-looking, where AR and VR devices are used more as general purpose personal computing devices in a variety of settings. And I'm thinking about a couple of things fundamental to these devices and how they could affect our interactions. So in VR, we have that users are visually isolated from their physical surroundings, and in AR, users interact with virtual objects that include just part of their physical surroundings. So from these, we can get to that each AR and VR user coexisting in the same physical space has their own version of reality that is not necessarily shared with others, and also that each user in the same virtual space has their own physical reality that is not necessarily shared with the other virtual participants. So looking at the VR side of things, VR occluding the physical world can complicate things for the user because they still require some awareness of the physical world in case they want to not harm themselves or others, in case they need to interact with physical objects, and so that they can interact with others in the physical space. So, right, and then thinking about this kind of from the other side of that, VR occluding the physical world from the virtual participants. So for a given VR user, the people that they're interacting with in a virtual space do not have access to that VR user's physical space. So you can think of in a virtual meeting, a VR user might be interrupted by someone or something in their physical space. And then to the virtual meeting participants, that VR user's avatar might behave strangely when they are reacting to that person. So this causes a reality balancing predicament in VR, where users have to balance their awareness and their interactions across both their physical surroundings and the virtual world. And there's a similar problem with AR, although not with complete occlusion of the physical world, but confusion with the physical world because some content is just not in both at the same time. So in a similar example, someone in the physical space might, in the same physical space as a given AR user, might assume the AR user is aware of them, while the AR user is actually attending to a virtual object or avatar that is placed over or nearby the real person, the physical person. So, and then also similar to the VR problem, someone in the virtual space does not know about the AR user's surroundings and who or what they are interacting with in that physical space. So this reality balancing predicament is one where the virtual world overlaps with the physical world in more of a confusing way. And this and these problems multiply, as you can imagine, with more users. Each of them have their own physical and virtual space, so the problem multiplies quickly. So and then thinking about this as thinking to address these things in a dissertation. First, I want to understand the problem space, both socially with respect to those interactions that occur, and individually with respect to how an individual balances realities mentally. And from there, thinking about how AR and VR in particular complicate those things or affect them, and then devise technical solutions and test those. So in some of our previous research, I've looked at investigating how different representations of a non-VR interrupter affect the experience of a VR user. So somebody comes up and interrupts the VR user, and they're represented a couple of different ways, either with no representation through the pass-through view or as these avatars. And we studied diegetic avatars, or avatars that thematically fit with the virtual environment. And we found that those diegetic avatars that fit, so the office characters, led to the best user experience for the interruptee, for the VR user. And interestingly, the participants preferred the partially diegetic avatar with that green outline because it helped distinguish it from virtual objects. So they said that it made it appear more human by adding that green outline to it. And then another thing that we found was that the avatars represented inside the virtual environment afforded the highest continuous sense of place illusion. So before and after the interruption, they had a continuous sense of place illusion, where the interruptions that required them to visually leave the virtual environment caused a disruption to that place illusion that did not recover immediately to the level that it was before the interruptions. So we've also looked into this from the interrupters perspective, that VR interruption scenario. This is not yet published. This was a pilot study, but we're thinking about a VR workplace scenario where where the user is not moving as much, which could make it more difficult to determine a good time to interrupt them. So I made this prototype with these LED lights that are supposed to show the virtual activity level of the user, and low, medium, and high activity levels. And it seems like they could be pretty useful for improving the interrupter's experience in terms of their confidence interrupting, because they restore some of those cues, or they restore the interrupter's ability to attribute mental states to the VR user, which is something that we do when we interrupt people normally outside of the VR context. So going forward, would like that to not be just a pilot study and do a more complete investigation of what kinds of cues are desired by the interrupters of VR users, and how the interrupters use those cues, simply how they think of them, and what their process is for determining a good time to interrupt. And then some other, I guess, bigger research questions, but how do reality transition mechanisms, for example, mechanisms that transition users in and out of VR or to different points on the reality virtuality continuum, or from one virtual activity to another, how would those transition mechanisms affect users' reality balance and strategies and experience, for example, in terms of their kind of overall mental presence. And also, I'm interested in these interactions in an AR context as well. And that is it. So I look forward to your questions and feedback.
Oh, thanks, Matt. Okay, so you're right on time. So yeah, we have some time for questions from the audience. Steve, I saw your hand go up.
Sure. And there's a lot of really interesting issues here, Matt. And one thing that occurs to me is that it's not just what kind of reality someone is in this whole big, broad range of different kinds of realities. It might also be the need to know, or maybe even the relationship between, say, the interrupter and the interruptee. For example, if you know someone really well, they may be very comfortable not only having a green, red, yellow light, but even sort of showing you what they're doing. I'm thinking a little bit of some of the stuff that Masahiko and Nami did with a little projection on the floor around someone that sort of showed a little map of what that VR person was actually experiencing. So you could imagine that if you knew someone well, they might not only tell you that or let you know they were not able to be interrupted, but you might even see what they were concentrating on. And if you didn't know someone well, maybe they would just simply say, sorry, you can't interrupt me. So I was wondering if you thought about that additional issue of the actual relationship between the folks involved.
Yes, yeah, there are a couple, yeah, as you've noted, couple interesting and complicated things there, because we asked people about that in our interrupter pilot study, and got a couple of things. Like I think most people had said that they didn't want more information. I think some people were thinking like I wouldn't want like all of my screen to just be projected to my coworkers. But yeah, I could see how if you're really close with somebody, maybe. Yeah, the context is pretty important. I'm thinking about like if I'm playing a game, I would probably even want that to be shared because somebody might find it interesting if they want to, if they want to also be sharing my experience in a passive way. Yeah, and yeah, it would be interesting to see what people think in like in a workplace scenario.
Yeah, and even with games, I mean, there's a huge difference. You know, if you're really good at something, you'll be very proud to share it with everybody. If you're
Right.
not so good, you might be happy to share it with people that you know well, who maybe also not so good, or even
Right.
people you know well who are really good, because maybe they would perhaps be willing to go and help you a little bit, but you might be embarrassed to be seen as an obvious newbie by the world at large.
Yeah, sure.
Thank you.
Rick, go ahead.
Yes, thank you. Thank you for the interesting talk. So this may be slightly beyond the scope of what you talked about, but you addressed this question at sort of the individual level, and then you went to the cultural level, or the society, the social level, but not to the cultural level. Might you consider thinking about, since you're already sort of in the realm of speculative futures, right? How might people react if it becomes common to have such technologies and to have to interrupt people with such technologies, right? So I'm just putting that thought out there. You don't necessarily have to pick it up, but I think I would welcome your thoughts.
Yeah, maybe could you rephrase that? Maybe, so are you talking, when you say cultural, are you talking about like a workplace?
So potentially a workplace, or potentially a society in which it becomes common to have Google Glass, for example, right? Where it is not the unusual thing to be immersed in VR and be interrupted by somebody who is not, right? So again, this may be beyond your scope, because I think you are pretty well targeted on sort of technological improvements or adaptations or solutions to these problems, but I think it might merit thinking about how this problem space will change as more and more people use head-worn display technology.
Right. Yeah. Yeah. Thank you for that. For that note, I think that is definitely important to keep in mind, because yeah, I think that's one of the things I've been is a common struggling point for me, is like, is this just going to be a non-problem? Like this one, like a particular thing, like, are people just going to get used to it? What does actually change? What can we adapt to? And yeah.
Okay, I think we reached time for discussion. I hope I didn't cut you off, Steve, but we'll have time later to discuss. So thank you so much, Matt. Okay, so let's go on to our next presenter. I lost my page here. Prasant, are you ready?
That's me. Yep. So good morning, good afternoon, good evening, everyone. Can you guys hear me? Okay. Cool. Okay.
Yes, we can.
So my name is Prashant. I am from the Empathic Computing Lab from the University of Auckland. So my thesis is using multimodal input in remote collaboration, essentially. So I'm a third-year PhD student. So what I'll be going through is the work I've done so far and the work I'm doing and my future plans. So essentially, my PhD, as in remote collaboration, can be concise into this picture. So there are 3 stages for 3 parts of the PhD. First one is essentially a reconstruction of the scene. Oh, before that, I should explain what is the main goal of my PhD. That is to see what the effect of incorporating multimodal cues in remote collaboration, mainly in terms of presence, engagement, and task efficiency. So to do that, I've split up into 3 parts. One is scene reconstruction, which essentially is that assuming that there's a remote person trying to help a local person, the remote person would be able to view the local person's scene. That is, the local person would be able to capture and stream it to the remote person. That is the first part of the PhD, which is scene reconstruction. Second part is the physiological sensing, as in trying to share the physiological cues between the participating agents and try and see what kind of effect it has on the collaboration. And the third one is essentially a combination of both, which involves sharing the physiological cues as well as the surroundings in a remote collaboration. So to start off with, the first thing that we did was to compare user-centric and device-centric cues. That is, assuming, so for the rest of the talk, just assume that When I say remote collaboration, it's mostly a local person trying to do a task, and there's a remote expert somewhere else trying to guide this person. Okay, for that, first thing we tried was to compare user-centric versus device-centric cues. User-centric as in you use a pen to draw things like annotation in three-dimensional space. That is user-centric. That is device-centric, and user-centric is basically natural human gestures like your hand gestures, your eye gaze, etc. So first thing we did was to put a couple of Intel cameras, depth cameras. We captured a table, reconstructed it, and played it in a remote person's VR headset. And that person's hand gestures and eye gaze was visible for a local person wearing an augmented reality headset. So what you see on the right side is the view from the augmented reality headset. So you have a device-centric cue and a user-centric cue. This was published in ISMA. And we took this further and made a cluster of cameras that can be attached onto the ceiling or onto the table. When attached to the ceiling, it can reconstruct the entire room space. So we did that with 24 participants, the same study, and we found that combining gaze and gesture cues were provided a significant stronger sense of co-presence. So another thing that I did was so this was a paper I co-authored on, which one of my colleagues who was working with spatial audio, she was interested to know how spatial audio could be used in remote collaboration. So we essentially used the same system and incorporated spatial audio. And with spatial audio, what we did was you had tasks like, say in this task, you can see that there are Lego blocks in the space. The task was to find these Lego blocks. So we used different methods, as in different conditions. One was to have normal audio cues. One was to have spatialized audio cues coming from the Lego block that they need to pick up. One was the person guiding in normal voice, and the one was the spatialized voice. So we found that in general, the spatialized awareness in remote collaboration enhances the ability to pick and place objects in scene. This was published in the Journal of Multimodal User Interfaces. And then we did a training system. So with the previous system, we had a system where we could capture and stream the surroundings from the depth camera. This time, what we did was to capture the surroundings in depth camera and save that as a stream, and then use that for training purpose. So in this case, this was actually in collaboration with Air New Zealand, which is the New Zealand Airlines. So what I did in this was essentially had 4 different visual cues. I was comparing 4 visual cues that could be used for training purpose. One was annotation, another one was hand gestures, another one was a character representation, and the last one was a volumetric capture. We were trying to see which one provided the best co-presence in a training scenario. We found that even though the volumetric playback was not the best in terms of efficiency, it provided the most sense of co-presence and usability while reducing the mental workload. One more work that we did in the first part of this research was when we went into lockdown, we made a system that designers or teachers could use to, or students could use to showcase with the teachers the work they've done. So normally the calls are on Zoom. Instead, if they have a 3D model to discuss, they could bring the 3D model into VR and then stream it to Zoom. So this system was published in the late breaking work last year, and the user study is still pending. So this is the part of PhD where I'm currently working on mostly, that is the physiological sensing part. In this one, what I am essentially doing is that I have 3 hypotheses, which are almost variations of each other. Just one is performance, co-presence, and immersion. How does that affect in terms of remote collaboration when physiological cues are shared? So in this system, what I'm using is I'm having a wristband for a shimmered band for getting heart rate and cognitive load, Lucid headband to measure the attention, and using this information in a remote collaboration task. In this one, apologies, I should have used a proper setup picture, but I could not put it in. So in this case, what I'm having is that you have 2 people in virtual reality, and then they have an engine that they need to disassemble. In this one, they would be able to see each other's physiological cues. So we have the 4 conditions in here: heart rate as a base condition, and heart rate and cognitive load, heart rate, attention, and all of them together. So in this So there'll be follow-up study of this one, which would be done with 12 to 15 participants. And we'll be using a set of questionnaires to measure. Not sure how, I think I have about 2-3 minutes. Okay, cool. So that is the second part that I'm currently working on. The third part is essentially a combination of both. In this one, what essentially is going to happen is whatever the result of the second study was, that is whichever physiological cues were the prominent in sharing in a remote collaboration setting would be used in a live reconstruction remote collaboration system. So this is where I am in terms of my progress. So I have 2 more main user studies to conduct, and then it's writing and thesis submission by the end of October. So in general, the main feedback I would want was a validation of my second study, which the system is all built in. I'm about to conduct the study. These are the conditions that I'm evaluating. And my approach in general, and any other similar or important literature work that I missed or that you've seen is related to mine. Also, most of the user studies I've done is related to mechanical engine disassembly or assembly task. So there are a couple of collaborators who are working in medical field as well. So these would be the applications of my research. If there is any other application that you think that I would be able to connect to, that would be great. Yeah, and that's it. So thank you.
Excellent. Thank you, Prashant. Okay, you're right on time. So ready for questions?
I was either very clear or I wasn't.
Oh, I do have a question in chat here from Joe Gabbard. You mentioned measuring immersion and co-presence, yet present results based on usability and mental workload measures. How are you differentiating immersion and co-presence?
Can you rephrase that question?
He says you talk about measuring immersion and co-presence, but your results were based on usability, mental workload measures. So,
yes.
yeah, okay, go ahead.
Yes, so those were the results I mentioned. So what I've used for the studies were System Usability Questionnaire, NASA TLX, SEM, the questionnaire. I also used a questionnaire for measuring spatial presence, co-presence, and I can't remember from the top of my head what the questionnaire was called, but I did measure all of them. But I did not, the point where I did not mention it was the point where I did not find any correlation between the conditions for co-presence. The point where I mentioned that there's only usability is because there was, we did not find a strong correlation between different conditions in terms of co-presence in that. I don't think I was clear. Let me rephrase that. In the first condition, in the first experiment, what I mentioned about the usability while lowering the mental load was because both those qualitative measures gave us a significant result. So that's the reason why I said specifically that those were the findings of the study. Hope that was clear.
Makes sense. Yeah, thanks.
Yeah.
So that's another quick question for anyone? Okay, thanks, Prashant. I think that's
thank you.
Time. So yeah, thanks so much.
Cheers.
Okay, Hiroshika, you are next. Are you ready?
Yes. So let me share my screen. Okay, so I'm Hiroshika Premratha. Hope you, okay, before starting, hope you can hear me.
Yes, all good.
Okay, thank you. Okay, I'm Hiroshika Premaratna. I'm a PhD student at Victoria University of Wellington, and my supervisors are Dr. Stuart Marshall and Dr. Nadia Pantidi. My thesis topic is a mobile intervention to promote social skills in children with autism spectrum disorder using AR face masks. So autism spectrum disorder is a lifelong neurodevelopmental disorder characterized by the deficits in social interaction, challenges in communication, and repetitive rigid behaviors. According to Diagnostic and Statistical Manual of Mental Disorders 5, social emotional reciprocity, nonverbal communicative behaviors, and developing, understanding, and maintaining relationships are included as social skill deficits. Human face plays a main role in social communication. Children with ASD have difficulty in identifying emotions and having face-directed eye gaze. Because of that, they are struggling to have friends and interactions even with the close family members. Dr. Stephen Shaw has mentioned, if you have met one person with autism, you have met one person with autism, because each autistic individual is different from each other. They have different characteristics for each person. Although there are numerous behavioral therapies available to promote social skills of autistic children, there is an issue with the availability of therapists and the number of autistic children who are in need of the therapies. Although the evidence-based research have shown that the effectiveness of the treatment outcome is greater the younger the child with autism begins the behavioral therapies. Due to the long wait lists for admittance or unavailability of behavioral therapists, many autistic children are unable to start training early. So it shows the need for alternative and complementing approaches to tackle this problem. A considerable amount of research has been carried out using digital and mobile tools to address this issue. Wearable devices, virtual reality, and augmented reality lead the research in this domain. But these studies have their own issues as well. In VR, some setups require large spaces. It isolates the child from real world and insulate in virtual world, and there is an open question whether the skills developed in virtual world are actually valid in the real world, because finding the relevance of the social skill in different social context is difficult for autistic children if they are trained in a different setup. AR-based wearable devices are intrusive and children with ASD are reluctant to wear additional devices. Some are not even available for public use, such as Google Glasses. Also in AR, effectiveness of using AR-based masks in the interventions has not focused in the existing studies. However, in summary, most of them needs expensive hardware, or some are early prototype devices, or they need laboratory or special setup, and some are not even tested for usability with autistic children. In the study, my main research question is how an AR-based mobile application can be used as an alternative intervention method and a communication method in social conversation of autistic children with their close family members by maintaining face-directed eye gaze and emotion recognition. I'm going to find a solution for the main question through these sub-questions. Do the AR face masks foster the maintenance of face-directed eye gaze during the conversation? Do the AR face masks enhance the engagement of the conversation? What features can be altered to create more customized AR face masks for children with ASD? How storytelling can be used to identify the emotions of the characters in a specific situation, and is this skill transferable to similar real-world situations? To answer these research questions, I am suggesting a mobile intervention in the form of discrete trial training and incidental teaching. Discrete trial training is a behavioral technique used in applied behavioral analysis method. This intervention, mobile application, suggested to promote emotion recognition and face-directed eye gaze of children with high functional autism spectrum disorder. Also, this will incorporate face masks, storytelling, and video modeling techniques in the application. This research focus the children with ASD within the age range of 6 and 12 years. The application is composed of two components for emotion recognition and face-directed eye gaze. Face-directed eye gaze component allows the child to take a video call to a parent. When the parent answers the call, his or her face will be overlaid with synchronous AR face mask as a discriminative stimulus. When the child do the face-directed eye gaze for pre-decided duration or a frequency, the AR face mask starts to fade away and reinforcement will be provided to the child. In emotion recognition component, when the child selects a category, storytelling video is played and it will be stopped at a place where emotion can clearly be identified. A pre-recorded explanation of the situation will be played as a discriminative stimulus. The child needs to choose the correct smiley relevant to the video then. In this application, 7 emotions will be tested according to the facial action coding system suggested by Paul Ekman. Differential reinforcement is provided here based on the provided answer by the child. This is the initial design, and the development of the application will be done through co-designing process with children with ASD together with iterative evaluation approach. I conducted semi-structured interviews with behavioral therapists to understand the existing methodologies and tools used by them to support emotion recognition and face-directed eye gaze. Some of the suggestions are incorporated in this initial design as well. There are 2 contributions from this research. First one, a mobile application, which will function as an alternative communication method and therapeutic intervention in the form of discrete trial training and incidental teaching. Secondly, inform the effectiveness and level of user satisfaction of user AR masks, storytelling, and video modeling through co-design process together with iterative evaluation approach. Within this DC, I would like to discuss about or any suggestions about how possible is it to generalize when providing reinforcement to different children on different parts of the spectrum. Secondly, what other possible evaluation approaches can be used to find the skills are transferable to the real world environment. Thank you for listening.
Okay, thank you, Hiroshika. So you're running out of time, so we have time for questions. Does anybody have a question? Bobby, go ahead.
Hi, thanks for your talk. So one of the issues that autistic kids have is with facial recognition. In fact, there are therapies that try to teach them how to recognize faces better. So have you thought about how your program would interface or interfere with those kinds of things?
I have considered several therapies that are existing therapies. So with the literature that I have gone through and with the interviews that I have conducted, so I came up with this discrete trial training method and the incidental teaching method. Because in incidental teaching method, like they are using whatever the techniques in the real environment, not in like kind of a setup. So they can like, because they have like main issue they have is like if they have trained or they have the therapy session in a different setup, they can't apply it to another different context. They can't understand that. So in that case, I am using the incidental teaching method, and also in discrete trial method, they have like proved like, okay, so this one is like it is proved to be successful in emotion recognition and face detected eye gaze in the manual process. So I'm trying to impose it in the mobile application so they can use it with that.
Okay. I mean, all right, that's fine. I'll let somebody else ask the question. Thank
you.
Steve, please go ahead.
Okay, sure. This sounds like a really interesting application. And it's one where I can see there's so many different things that could go wrong. It could be misunderstood by the kid with whom you're interacting. And one thing I'm trying to understand is, I was looking at figure 2 in your paper, which has very little explanation and lots of parts to it, and the caption literally doesn't tell us what the parts do. And I was looking at the lower right-hand side after it says select the motion of Jack, and then it looks like the X over sad is supposed to be what the kid is selecting, and yet crossing something out to most people means it's not that thing. So I was just sort of trying to understand what was going on there. And if the cross out is supposed to be selection, suggests that maybe you use some other kind of highlight that indicates that that's what the kid is picking.
Oh, it's that the suggestions are given. So when the child selects the wrong option, so it will be like opted out with the cross. So then they are given like several like tryouts so that they can like select it like several times. So like that.
So is the X supposed to be the kid selecting it, or is that supposed to be saying, no, it's not sad?
Yeah, the X is like, it is like opted out, and that is the wrong selection the child has done. So
Okay.
they can select from the remaining ones.
I see. Okay, so it really does mean that was wrong. I thought just reading this that it meant that was what the kid was selecting. Okay, that sounds much better. Yes. Okay, thank you.
Okay, I think that's time. Thank you so much, Hiroshika.
Thank you.
And now we're ready to bring up Kunal Gupta. Are you ready?
Yeah, I'm sharing my slide. Can you guys see the slide?
Yes, you can.
Oh, without the notes, right?
We do see like the web browser URL bar, but otherwise, I don't see any notes. Looks good.
Yeah, perfect. I can start now?
Yes, please go ahead.
Perfect. Hello, everyone. I'm Kunal Gupta, PhD student at Empathic Computing Laboratory in the University of Auckland. And today I'll be talking about my research on exploration of context and physiological cues for personalized emotion adaptive VR. The overall research objective for my thesis is to basically to check how to use the fusion of contextual and physiological cues to develop personalized emotion adaptive VR systems that can improve the engagement, presence, and flow state of the VR experience. To investigate that, I created an overview of my research where I categorized it in sensing, context awareness, and emotion adaptive VR, and I'll be talking in detail about these. For the sensing, I started with the first question, which is like how to objectively measure psychophysiological responses associated with emotions in virtual reality. So for that, I designed this experiment and called Effectively VR, and where we use physiological and subjective data to generate machine learning models to predict human emotions in virtual reality. For this, I used OpenBCI EEG cap and Shimmer to capture EEG and skin conductance data, while participants were watching immersive 360-degree videos in VR. This paper is published in VRST and can talk about it later in detail. Next, for the contextual cues. I wanted to investigate how much it contribute, the contextual cues contribute to the emotion construction, and contextual cues such as location or environment and activities. So the question for this particular study was how can affective environments impact the emotional states when the same activity is performed, or how can effective activities impact the emotional states when performed in the same environment. For this, I designed the study with positive and negative valence locations, which is a forest environment, pleasant forest environment, and a horror hospital scenario. And the activity was a painting activity for pleasant activity, and killing spider as a negative activity. And for this, I'm measuring EEG, heart rate variability, electrodermal activity or skin conductance, and pupil. And I'm using a self-assessment mannequin valence scale, valence and arousal scale for subjective measure. So we are also interested in, I'm also interested in determining if there's any correlation between these emotional contextual cues and physiological signals. Next, investigating the contextual cues further, I thought of exploring autobiographical memory. So autobiographical memory is a collection of past experiences that is remembered by people about their own life and are of self-relevance. So for example, like visiting Taj Mahal for the first time, or presenting first conference paper. And as we know that past experiences plays an important role in emotion construction, but how can we leverage the information to improve emotion recognition in VR? To address this question, I designed this study where I followed the autobiographical memory task in virtual reality, where participants saw the emotional word, positive, negative, and neutral word, and they had to recall the memory associated with that while they were in VR. And I measured the electrodermal activity, heart rate variability, and pupil. And through this study, I found a strong positive relationship between valence of the memory being recalled and elicited perceived valence. And through the machine learning classifier, I reported a 95.1% personalized cross-validation score if we are predicting if the recall memory is part of autobiographical memory or not. This was only with text, but next I'm designing a study with interactive VR. For this, I have a small video. Can you guys hear the audio?
Yes, we can.
So in this, basically 4 environments are created, and then I'm following a old mill scenario where the participant will be sitting on the cart to restrict the motion, but to add the self-relevance part using the sense cam paradigm, I'm asking them to click pictures and of any emotional environments they are interested in, and then at the end of the experience, I'm asking them to rate their. So this part is the encoding part where I'm asking to rate their experiences, and then this is the second environment example. And so after the encoding, after 48 hours, I'm asking the participants to come back again, and then teleporting them into familiar versus unfamiliar places, just to see if the physiology change, if we can identify the autobiographical memory through physiology in interactive VR system. So this was the contextual cues. Next is the emotion adaptive system. For this, there's a warning. The video that I'm showing could be a little bit loud and creepy, so please be mindful. So this was a demo that I presented at SIGGRAPH Asia, where we developed a emotion adaptive virtual wizard experience. So as you can see, the player starts walking, and the environmental cues such as fog and audio, it adapts to the person's real-time physiological emotional state. Moving forward. So for this particular study, the study design is to compare between a non-adaptive VR versus only physiology-based emotional adaptive VR or a context-aware physiology-based emotional adaptive VR. For this, I'm measuring physiological signals, EEG, electrodermal activity, heart rate variability in pupil, and then using subjective questionnaires to see their self-assessment mannequin scale, valence and arousal, game engagement questionnaire, eye group presence questionnaire, and flow state scale questionnaire. For the adaptive part, I'm using a rule-based dynamic difficulty approach, but I'm really interested in learning more about it if anyone knows about any other technique. From the timeline wise, I'm running this study for my autobiographical memory experiment and the environment or location and activity both contextual cues experiment, and aiming to finish my emotional adaptive VR experiment by September, and aiming to submit the thesis by end of this year. I'm also organizing a workshop for researchers who are working in extended reality and physiology. So if anyone is interested, please send me an email or talk to me after the presentation. Thank you. I'm not sure how much time it took.
Oh, that's perfect. Fascinating talk. That's very interesting. Thank you. We're right on time, so we have some time for questions. Kyle, go ahead.
Hey, how's it going? We'll talk more later, but I'm kind of interested in where you're planning to go with this. It seems like you're really interested in game design. Is that something where that's sort of your primary target?
So right now I'm basically this is just a application area that because I have to finish my PhD with one particular experiment area. So otherwise this particular technique, so that's why I'm going for entertainment or gaming, but this could be used for emotional adaptive VR can be used for any like therapies or any sort of healthcare or training or any kind of applications.
So you seem to have a I know your models are maybe dependent on this being fairly high impact, right? Where you're really able to see those signals. Do you think that those are going to translate when the stimuli are not as intense?
Well, so the reason to add the physics, so there are a lot of researches where people used like there's an entire like a section called affective computing where people are using physiology to recognize emotional states. So there's an immense amount of research on that. But then I'm more interested in knowing how context provide more like how context supports that physiology and provides a better emotion recognition system. So I'm assuming, so definitely there could be a possibility so that if the arousal or the activation is not that high, I'm not sure if the model would be able to determine the physiology or the pattern properly. But then if I have the contextual information, and at the end, if I create sort of like a knowledge base where because I'm recording whether the particular event is part of their past experience or not. So since I'm using that, and then I can create a knowledge base, maybe I can use that somehow to leverage and support my model. But at the moment, I'm not entirely sure.
Thanks.
I hope I answered the question.
We'll talk more later.
Yeah, thank you. Steven?
Sorry, my smoke alarm is going off, but good question.
I didn't realize I still had my hand up over there. So I think I'm going to pass right now. Sorry about that.
No comments.
Anyone else have a question?
I would really need some advice from people who are working on any sort of adaptive VR or AR or any kind of XR, adaptive XR thing. Just to know like if my approach is correct. Yes, Rick.
Well, just to follow up what you just said, and maybe to get more context for myself or other people who might be able to help you, what is the sort of advice that you're looking for? It does seem like you're quite close to the end of your PhD. So is this sort of, this would not be large scale changes to your research design, but more targeted changes to like, how can you make a more effective adaptive VR application?
Yeah, so I'm more interested. So I'm already conducting the contextual part of the like experiments for that, but I'm more interested in like how can I use the emotion adaptive like the approach. So right now I'm using a rule-based DDA or dynamic difficulty approach, which is like a game design approach. But I'm not sure if there's any other approach that anyone can suggest that can help me in designing a better emotion adaptive. So I'm pretty sure that I would be able to recognize emotions comparatively better, but I don't know what to do after that. So one way is just use a rule-based or state machine thingy where I say that this particular game object provides this much variance, this much arousal. So if a person goes over there and if the person's response is not that much, then the environment will change just to manipulate the emotional state. And since it's a real-time emotion prediction, so I would be able to get a real-time, like a biofeedback thingy, and then the environment can keep manipulating. Yeah, so any idea on like context, maybe like how to better use contextual information, because right now I'm just collecting in contextual, the experiments are being done, but I don't know how, like I'll be integrating it in the final system. So any advice on that side?
I'm wondering, try to get some ground truth, although it's not
Yes.
really ground truth. You could get subjective responses. So you could ask people, you know, how well do you think this actually determined what your emotions were? If you can, for example, provide to them, if they haven't figured this out on their own, some indication of what your system thought was going on, and try to see if they believed that what your system was assuming was happening was actually happening from their own introspective standpoint.
So you mean in this last experiment, in this?
So in the
trainings?
experiment, because you're making some determinations based on your physiology based stuff. So I mean, either you're perfectly on the ball, or maybe you're a little bit off, or maybe you're a lot bit off. And sort of find out whether you're right or wrong, you know, to try to get some feedback from the people whose emotions you're predicting and guessing, to try to determine if they think you're right.
Yeah, thank you very much for asking this. I mean, so I have this thought, since it's a personalized one, so I won't have like a lot of data to train a model previously. So I'm thinking of using an online transfer learning sort of approach where I create like a core model first, and then ask the participants to calibrate first and get their feedback. And then while they're performing the experiment, I'm thinking of asking like a small pop-up questionnaire, how are you feeling now? So that I can train my model on the way and then improve it.
You know, we're a little bit over time, so I think we better wrap up.
Please, I would definitely talk about it more. Thank you very much.
Yeah, this is great stuff. Thank you so much.
So one more thing I wanted to say, and that's that how you react to stuff, right, may really depend on how other people are reacting to things as well. And I'm thinking about much VR, everyone has kind of the same basic experience, and here it can be very different. And so when people try to interact later and, you know, talk about the experience they had, it might be difficult to understand what the other person was going through if they had something completely different because they were feeling good when they entered it versus you're feeling bad. So having some way of having other people know what's happening to you would be interesting. Because they might not see the fact that your vision, for example, is being clouded or interrupted, or there's a lot of static or something, as in what you were showing. And I might not know that when I see you experiencing it if I'm in a collaborative system. So having some way of letting other people know that you're having something about how the experience you're having might differ from the experience they're having would be interesting.
Yeah, that falls in the lab interest of empathy. So like, how can you empathize other people, or how can you empathize like get empathized by others' reactions? So I think that would be the future work of my thesis. I would definitely be interested in understanding the sharing part as well. But since I've already stretched for 4 years because of COVID restrictions, so I don't want to get into more research questions.
I think we better move on, just in the interest of time. I'm really sorry to interrupt. Yeah, thank you so much. So Hansi, is it? Are you ready? Yudapola?
I guess it's Dimitri.
Oh, sorry, I'm skipping ahead. You're right. Dimitri, I'm sorry. Yes.
Hi, can everyone hear me fine?
Yes, we can hear you.
Yep, okay. It's just that I have some noise suppression, a little bit of noise suppression switched on, and I was wondering if I was gonna cut anything out. So, okay, well, that's good. That's a good start. Okay, I just share my screen. And we can get started. Okay. Let's see, right. So can everybody see the title card for my presentation?
Not yet. It says that it's working on it. I don't see anything.
Right. Okay. Maybe I'm not sure. I could be sharing the wrong screen. Maybe. Let's try this. How about now?
Nope.
Okay. I mean, if it says it's working on it, then.
It says you've started screen sharing.
Yeah.
Well, it says
it doesn't not actually sharing.
It says you are screen sharing on my end.
How is this? Is it like Google Slides or what is it, Dimitri?
Yeah, it is. It is. It's just.
Do you want to just send me a link or something, or did you already share the link?
I shared the link just about everywhere I could have in the I think it was the PCS portal, and I'm not sure where else.
Can you put it in chat now? Oh, I have it here. Okay, can I just share for you?
Yeah, sure.
Okay. Is this looking okay?
Yes, that's right. Thank you.
Okay. All right.
So should I just tell you when to?
Yeah, I'll just try to anticipate what you want.
Okay, sure. Hello, everybody. My name is Dimitri. I'm a final year PhD student at the University of South Australia at the Empathic Computing Laboratory. I've previously worked with Afyon Karahisar Health Sciences University in Turkey, working on head-mounted displays for teaching cardiac anatomy. So I'm quite interested in natural interaction with HMDs. And I'll start off by, the topic of my research, if we just go back, well, the topic of my research thesis is on augmented reality to support tangible user interfaces for teaching text-based programming languages to non-traditional learners, so learners from non-computer science backgrounds and so forth. Yeah, next slide, please. Thank you. I'll just start by outlining the motivation for this research and just going through findings of the literature and explaining how my thesis identified the research gap, and I'll round it out by going through the approach, explaining a little bit about the system design of a prototype that is being designed as an attempt to address this research gap. Next, please. So looking through the literature, it's easy to sort of identify three main categories of research into educational tools. These are TUIs, tangible user interfaces, GUIs, graphic user interfaces, and finally we have AR, augmented reality. And with just as a little explanation, tangible user interfaces, they use various physical manipulatives for both input and output devices in order to communicate the learning content. This includes things like toys, microcontrollers, block-based input devices, and also including robotics into this category because it has a concrete physical tangibility, which is common to TUIs. And it's often used for both input and output mediums. Then we have GUIs that have more of a traditional, either a desktop sort of PC screen-based input and output. And for input, we have traditional devices like keyboard and mouse. And finally, we have which uses a variety of either marker-based or markerless or a combination of the two of tracking at this stage to output virtual content through, we can either have HHDs, that's handheld devices, or handheld displays, sorry, or HMDs, which is head-mounted displays. And we can have also a variety of input methods. So apart from, blocks and sort of paper markers, we can use now gesture sort of based hand interaction and hand input for interaction as a way of natural interaction with learning content. So next slide, please. Just looking at the literature and also the market of educational tools, it sort of becomes clear that GUIs, they do tend to dominate the research and also the application domain, but they do bring with them some implications, such as implications for cognitive load, and this includes different types of cognitive load, and at certain times they may raise the cognitive load, both intrinsic and extraneous, due to the mainly both to the complexity of the interface or the system and the complexity of the learning content, because we're dealing with either some computer science concepts or syntax or programming topics. So next slide, please. And moving on to AR and R2Es. In the research, it's also to identify sort of three primary categories for their application. The first one is end user, and this can include both sort of real life applications like industrial maintenance settings, but also if we're talking about programming specifically, there's a tendency towards end user programming using AR or R2Es. Then we have sort of visualization environments, but these tend towards physical sciences and things that have a concrete visual model, something generally accepted in society and in semiotics. And finally, we do have some instances of applications for programming and computational thinking topics, but these tend toward more simple topics and for younger students. So there's an example of the, I think, Osmo TUI, tangible user interface, but without the AR. So again, it doesn't really combine the two in any case. So there are obviously limitations to at this stage to what people are studying using this technology. Next slide, please. Thank you. And just to sort of approximate, to visualize the distribution of this research at this stage, there seems to be, just judging from the literature, there seems to be quite a steady growth in research to do with the development of the technology itself. So there's quite a lot of research focusing on the hardware and the actual novelty of the technology. Then we have system design is somewhat stagnant. There is not a lot of research, I think, that looks at reasons for certain designs of various systems and with AR and R2Es and how these affect user behavior or learner behavior, if we're talking about educational tools. And finally, we have research into actual evaluation methodologies. So a lot of literature reviews and surveys of various environments do tend to focus. There's quite a large output, but it's also kind of stalled at sort of using at times subjective instrumentation. So a lot of usability studies, engagement factors. I've even seen a study that looks at the fun factor of a learning environment, which is not to say it's not useful, but or valuable, but there doesn't seem to be a lot in the way of gauging user behavior while using a system. Next slide, please.
Dimitri, you're pretty much at 8 minutes now, so you might want to just quickly summarize your research, and then we better get to the questions and move on.
Well, okay. Well, this actually, this is the research, to be honest. But again, this is the thesis identifies the need to go through a variety of different individual activities that are part of a interpretation programming matrix. So next slide. And these are the research questions. I go into some detail about this in various publications, and in another publication that I've submitted to IEEE VR specifically on the proposed prototype system. Next slide. And this is the underlying design principle for this system, is to happily marry the learning space and the programming space. Next slide. And I already have some previous publications, and the thesis also so far goes into the way that these concurrent spaces can be combined. And there are more details in other publications. So don't bother trying to understand this at this stage. It's just an illustration. Next slide, please. And we can just skip this. Next slide. So at this stage, the future work is to finalize a prototype system specifically for the HMD variant of the system. I'm using a variety of theory from literature, just educational theory, and also to finalize what data collection instruments will be used for the evaluation methodology, because it's important to look at specific activities and operations during the learning and the programming activity while using the environment. So next slide, please. We can skip this. This is the teaser video. It's available. I don't think we have 30 seconds, but so that's sort of a summary of my research. Thank you for listening. And if anybody has any questions, I'll be happy to answer them. Thank you.
Wonderful. Those were beautiful slides.
Thank you very much.
So well designed. That was great. Okay, well, we have time for one question, I would say.
Okay.
Yeah.
Better make it a good one.
Yeah. Steve,
I'm sorry you had to.
Yeah. If anyone just wants to go ahead. So would you characterize your work, Dimitri, as kind of the survey, kind of putting together the survey, or
the main goal of this research is to undertake an interdisciplinary approach. So it's not the system design it's the system design. It's how we can use the affordances of specifically the HMD AR 2E medium to find out what the best way to design such a system for learning this specific subject is, as well as how we should evaluate. So I'm not offering a specific evaluational methodology, because at this stage, looking at the literature, there doesn't seem to be a specific suitable evaluation methodology that looks at specifically this medium and this learning topic because I'm focusing on senior secondary high school students. So it's a very sort of specific set of criteria that is being looked at. And that's why it's at this stage, the study design is being quite, it's being worked on, but it's not an easy task because it will involve field studies with quite a large cohort of high schoolers, and it needs to be a comparative evaluation between the two mediums, HHDs and HMDs, but also possibly just pure raw TUIs without any sort of display devices. And there are already directions as to how we can evaluate it, mainly by pre and post tests of simple programming. It's programming instantiation statements in the Java language. So we're looking at that. And also behavioral analysis, so coding specific behavior, so how the frequency of block placement and the order of the block placement. So we're using a block-based system, I forgot to mention. So it's a very finicky and
yeah, it sounds complex. It sounds really interesting. Yeah. I think we better wrap up because we're a little bit over time, but I'm sure, the mentors here will have some great ideas for you. It sounds really interesting.
Okay.
Let's move on to the next talk. And Hansi Udapola, sorry, I kind of jumped ahead earlier, but are you ready now?
Yeah, Hansi Udapola. Share the screen.
Okay.
Can you see?
Yes, it's working. It's good.
Okay.
Go ahead.
Okay. So, hello everyone. I'm Hansi and I'm a first year PhD student at Victoria University of Wellington. And today I will present my PhD research project, which is titled on Gamified VR for socially isolated adolescents with significant illness. So at the beginning, I will start with something familiar with you because everyone know how COVID-19 impacted the world. So I guess you all experienced the home isolation for somewhat level. So know that during this time period, we're not allowed to go anywhere and we had to stay at the homes and had to maintain the social distancing. So sometimes all this experience, you might have some feel of confinement because of it, and sometimes stress because of the inability of maintaining the usual social contacts. So sometimes this also could affect on your mental well-being as well, because it could be affect on different people in different ways. However, can you imagine how hard this experience for an adolescent? Because you know that adolescence is a kind of time period that happen in a significant level of physical and mental transformation. So usually during this time period, adolescents seeking for more social relationships, and actually friends play important role in their life as well. So if they had to socially isolated, then it could be more challenging for an adolescent. So think, what if an adolescent diagnosed with a significant illness like cancer or cystic fibrosis? They face various range of psychosocial and mental well-being challenges. So among them, the social isolation is one of the major psychosocial well-being challenges that they are facing. Because of this significant illness situation, actually they require to stay at hospitals for a long time period. And because of the immune compromised situations, they also have more restriction on social engagement, because it doesn't matter it's their family or the friend. Also, they also in the recent literature also specify that social interactions with friends is quite unmet need for this group of adolescents. And actually, adolescents who are diagnosed with the cancer are considered as the most disadvantaged and the isolated group in the healthcare system. So with considering all these limitations on social interactions, this all could be affect on their negatively on their mental well-being, emotional and psychosocial well-being. So also when we considering the concerns on physical appearance and body image is another problem for this group of adolescents. And because as you know, the teenagers are usually care about their appearance, and if they have experienced some kind of the physical changes like losing hair, so because of this treatment, actually like chemotherapies, this experience could be negatively affect on their mental well-being again. So some adolescents might push back from social engagement as they don't want their friends to see them like that. So when looking to some existing literature in the research in this context that's carried out to address those some of the issues, they are mainly belonging to the text messaging and video calling and social community-based interventions. And these all interventions are actually trying to provide some opportunities for social interactions, as it is identified as a strategy in psychology in improving the social isolations, loneliness, and social connectedness. So however, when considering the embodied interactions that happen in between the other person, and immersive collaborations, interactions, and the social present user experience are limited in this existing interventions, specifically within this space. So when considering these limitations, the social VR could be a good way to address those limitations. So as it has the ability to provide in the in-depth communications with embodied user interactions and also social present user experience, which is known as a crucial component in social interactions. And also not only that, each of the players are represented by an avatar. So using social VR is a good way to improve the social engagement of adolescents who have concerns on their physical appearance. And however, when considering the effectiveness of using the social VR specifically within this context is quite is understudied, and actually need further research on design strategies, specifically about this group of adolescents who are considered as the sensitive groups within the hospital settings. And in addition, when considering the previous interventions categories, actually there is a research space of serious games as well in improving the well-being challenges of this group of adolescents. However, when considering the objectives of these serious games and the gamifications, they are mainly focusing on enhancing the psychoeducational outcomes and has been used as a tool of the distraction from the pain, as well as the enhancing the engagement with the physical activities. However, the empowerment effect of the game elements in social engagement is actually need further studied with this group of adolescents. And also therefore, in this research, we are mainly focusing on how can gamified social VR improve the social engagement of social isolated adolescents with a significant illness. So in regarding that, actually, I'm going to research in how to implement the effective social interactions mechanism within that gamified social VR space for this group of adolescents. And in order to achieve that, actually, the challenges and needs associated with the social interactions for this group of adolescents will be evaluated, and then to what extent actually can missing the social interaction can be supported and mapped out with the different game mechanics will be researched. And also next, the user studies will be carried out to evaluate the user engagement and to validate their social interactions against their requirements. And as the second research question, I'm researching on the empowerment effect of the game mechanics on social engagement, and also finally researching on participants' experience to evaluate the impact of the design environment on indicators of some of the social isolation and in group of these adolescents while they are in long-term care. And as the proposed idea, actually we intend to provide the positive social interactions for hospitalized adolescents within that gamified social VR space, minimizing the negative interactions like nausea. And in this interventions, we are going to try to connect the adolescents in long-term care with their friends from the home or the hospital environment, or sometimes with their friends, sometimes with their family members as well. And also here we are using the game technologies will be integrated within this space, and actually we are integrated it as an motivational factor in user engagement as a strategic attempt to enhance the social engagement. And as the research methodology, actually we intend to follow the user-centered design approach, and currently I'm in the stage of the requirement gathering phase. And in order to specify the requirements, as the first stage, we decide to recruit the healthcare professionals as participants instead of the adolescents in long-term care, because health care professionals have the experience working with many of the adolescents in long-term care under different conditions. And as the second stage, we intend to survey and interview the adolescents in long-term care. And once the design solution is developed based on that gathered requirement, then their feedback will be used to refine the design of the interventions in an iterative way. So here's the end of my presentation, and these are the few of the questions that I would like to discuss with my mentors.
Thank you. Great, Hansi. All right, you're right on time, so we have some time for questions. Oh, Alicia, go ahead.
Great job. That's really awesome. I know a lot of us here are very interested in this topic, so thank you for sharing. As someone interested in this topic, I can say that the ideas of putting gamification in a social environment sound very general, but you kind of have to get pretty specific. Have you thought about some of the specifics of what you think this environment's going to look like, or at least your kind of first iteration?
No, actually, currently I'm in the first stage, so therefore currently I'm gathering the requirements from their user, actually the participants, which means considered as adolescents in long-term care. Still, I didn't reach them. So actually, based on the requirements that I gathered from the healthcare professionals, they are specified some of the requirements as they have seen when we are, because they have experience with their adolescents in long-term care. So they specified some of the needs, like celebrating parties are kind of a major thing that they have missed, and the not being in outside of the world is kind of a thing. So likewise, I still am on analyzing and still in progress that collecting. So that's not analyzed the entire results. So likewise, they also have specified, but once I reach the adolescents in long-term care, then I can identify what are the actual needs for them. And also I'm using that social VRs because the advantage of there's some advantage of using the social VR, and I actually maybe I have seen some the literature, but I didn't realize that some of the using the the effectiveness of using the social VR specifically for this group of adolescents is I didn't that realize how they have that actually the effective of using social VR specific in this group is quite understudied. That's why I'm going to study well, and then going into the gamification also added as an enhancing the engagement, because IEEE hypothesis if they engage well with that interventions, then they are once someone in the healthcare sector, then they can have another research on what is the long-term effect on their psychosocial well-being once they have some engagement in long-term.
Sounds great, and thank you for sharing. I'm excited to see what you come up with over this process.
Thank you.
Rick, go ahead.
Yes, Hansi, thank you very much. I am also someone that's very interested in this topic. Some colleagues and I have been talking about sort of a similar problem, and I think this is a really great use case for social VR. I was wondering, so I honestly don't know the answer to this, so I'm just putting it out there as an idea. Is there a reason why you are specifically setting out to design a new thing versus evaluate the suitability of an existing technology for this purpose, whether that, whether that's a configuration of Rec Room VR or AltSpace or whatever the case may be? An existing social VR platform could be, configured or modified to serve this purpose.
Yeah, actually, we have some planning on that, because we have not exactly said that user studies, how we are going to put that user studies, because I currently still am in first year, and so I'm working on that. And actually, at the beginning, we are going to try now to evaluate the effectiveness of using the social VR. Actually, we are going to compare there are some suggestions that comparing the because we can add elements in even the texting and other elements that they are using to communication. We can put those elements in the VR space as well, and also we can compare with the real world. Because really we are using texting and using their phones is another way. So we can compare the social VR at the beginning, but later on, but how we can enhance their engagement by using some designing strategies specifically for this group. That's why we are again collecting the direct requirements and needs from their adolescents. So likewise, again, then we are moving to the customizing. So it's the second step. The first actually, and also the reason for using the social VR is because it's a kind of a hypothesis, because there are so many technologies also available because in this space, and also then I realized that robot technologies also has been used, but not with the adolescents, but because I have analyzed the literature in the children's and the adolescents. So when I go into the children's, they have used the robot technologies as well, and but it's quite when considering the cost of these, so it's quite high. And also, and when we come to the VR, actually again using the VR is a good solution than I identified, but again there is quite limited in using the VR only to connect to the real world environment, like to the schools they have used, but that interactions that happening with the other person is quite I didn't realize that they have studied that interaction. So that's why trying to use the social VR and then going to modify in order to enhance the engagement and actually meet their needs.
Okay, we are a little bit ahead of schedule. So Andrea, I see your hands up. If the question is not too long, maybe it'd be okay to ask it. Oh, you're on mute, actually.
Sorry,
Okay,
everyone.
no problem.
I'll be super, well, I know we're going to talk later. So I essentially was asking if you had thought yet about how to accommodate the specifics of a hospital setting, but it sounds like from Rick's answer that you are thinking about that. And I totally applaud your talking with the healthcare workers as well as the student participants. So I will say it doesn't hurt for us to be a little bit ahead of schedule. So I'm going to say that was a great presentation. I'm looking forward to talking to you in detail in our one-on-one.
Great, thank you so much. Okay, great job, Hansi. Okay, so we have one last presenter in this session. That'd be Nisal. Hopefully I'm pronouncing that correctly.
Hey, I'm going to share my presentation.
Great.
Right, can you see the presentation?
Yep.
Okay, all good. So I'm going to start, right?
Go for it.
Yeah. So hello everyone, I'm Nisal, one of the first year PhD students in Victoria University of Wellington, New Zealand. My research is for XR for improving cardiac catheter ablation procedure, and my supervisors are Dr. Craig Anslow and Dr. Brian Robinson. So this is the prototype that I have developed. The heart beats in rhythm to maintain an effective blood supply to the body. Cardiac chambers, atriums, and ventricles coordinatively perform contraction and relaxation in order to eject and fill chambers with blood. This coordination is controlled by an electrical signal that travels through conduction pathways of the heart wall. However, due to changes occurs in these conduction pathways, the electrical signals may travel through abnormal pathways in the heart, which may, in which way the coordination is compromised and the abnormal heartbeats occurs. So in that condition, we call it cardiac arrhythmia. Arrhythmia makes the hearts to beat in slower or faster or irregular patterns to the healthy heart rate. And also it decreases blood supply to the body and increase heart problems. Although medications is used as a first-line treatment for arrhythmia, it has significant side effects. On the other hand, the catheter ablation is a treatment with a better therapeutic outcomes. So let's examine what the catheter ablation is. Catheter ablation is a procedure, it's a minimally invasive procedure performed clinically to
Misal, can you hear us?
I've had Zoom just crash on me a couple times today, so maybe that happened to him. So, Nisal, are you able to hear us? We are muted, but you were frozen. So
Yeah. Okay. In which slide that you have missed?
Okay, yeah, here we are. Yeah, okay, go for it.
Okay.
I think the next slide, yeah, this one.
This one. Okay. Sorry about that. Right. So catheter ablation is a procedure. It's a minimally invasive procedure performed clinically to disrupt abnormal conduction pathways and restore the healthy heartbeat. So this procedure starts with the catheter insertion to the heart. When the catheter is inside the heart, the electrophysiologist navigate the catheter inside the heart in order to study the electrical activity. For this process, they use electroanatomical mapping system to create a 3D anatomical structure of the heart, as well as the electrical information is embedded as the color-coded surface. So this map they use to diagnose arrhythmia and decide ablation strategy. So finally, the ablation or the burning process is performed to disconnect abnormal conduction pathways of the heart wall. So this procedure is beneficial from the patient's perspective. However, from the electrophysiologist's perspective, this is a challenging procedure to perform and even more challenging procedure to master it. So that's why I consider both the procedure training scenario and the intraoperative scenarios in order to discuss research problems. So when it comes to the procedure training scenario, every step of this procedure needs to be mastered in order to perform a successful procedure. However, the clinical practice is the only way to acquire these skills. So when the trainee comes to the training, the supervisor does not have an understanding about the trainee's competencies, as well as the trainee also does not aware about their strength and weaknesses. So at the training, trainees are not allowed to perform the whole process at once. Training supervisors give tasks from easier ones at first and then move into the more challenging ones. So if the trainee takes too much time, the supervisor takes over the procedure and finishes it because due to the time limitations they have. So in this training model, trainees learns separately each step at a time. So they cannot have a complete training. And also there are less opportunity for trainees to have try their own ways due to the patient safety. So the training supervisor has to maintain the patient safety, the procedure time, as well as the training the training of the trainees. So all these things should be maintained during the procedure. So also there can be arises of ethical issues due to actual patient involvement to the learning curves of the trainees. So that's why as a solution, I will develop a procedure training simulator which is an AR application to improve the readiness of the trainees before they go to the clinical practice. So this simulator facilitates immersive training environment with actual patient data where they can try out their own ways to improve their skills. Also, this will help them to practice skills repeatedly until they master them. And also assessment modules can be conducted where the trainees and the supervisors can have a prior understanding of the before they go to the clinical practice. So when it comes to the intraoperative scenario, which means the procedure is conducted during the procedure, diagnosis and the decision making are the major two cognitive tasks that the electrophysiologist perform. And when the arrhythmia gets complex, it increases the time of diagnosis and decision making. There's no additional support is given to the electrophysiologist to this diagnosis and the decision making process other than the visualizations. The visualization is a critical need to understand the electrophysiology and the anatomy of the heart in order to make diagnosis and decision making. However, in the current practice, they use 2D screens to visualize 3D structures, which does not offer depth perception. So that the electrophysiologists are required to mentally process the 3Dness along with the whole cognitive load of tasks. So also electrophysiologists are required to speak with a technician who operates the electroanatomical mapping in order to manipulate the visualizations for them, so that this verbal communications happens time to time during the procedure, interrupts the thinking process of the electrophysiologist. So as a solution, I will develop an intraoperative guidance system, which is an augmented reality application to use during the intraoperative diagnosis and the decision-making process. So it provides 3D visualizations in the 3D space, and also direct interactions where the electrophysiologist can manipulate 3D models as they prefer without having to talk to someone else. And also, and finally, this application can be used to find similar ablations which they have performed in order to eliminate the rethinking time and as an assistant for the decision-making process. So these are my research questions. Mainly, I wanted to find how XR can improve the effectiveness of the cardiac catheter ablation procedure. Following, I wanted to find how effective is of XR for these both of the scenarios. And finally, I wanted to find how XR can improve the decision-making, visualization, and as well as the interaction for the electrophysiologist. So I am using UCD to conduct this research, and I have conducted a literature review to understand the problem context, and also met with my clinical advisor, Dr. Darren Hooks, in order to understand the problem context. And currently, I am conducting interviews with electrophysiologists in order to identify the user requirements. So this is the prototype. Here I developed this prototype to represent the procedure training scenario with an immersive operating lab environment with access to the actual patient data that is exported from the CARTO 3 electroanatomical mapping system. So the 3D maps are reconstructed in 3D space and allows the user to interact with them as they prefer. And I have used Unity with Steam VR to implement the virtual environment and the user interactions. So thank you very much for listening to my presentation. And these are the questions that I would like to ask from my mentors. Thank you.
Very cool. Thank you, Nisal. Okay, you're right on time. So we have time for a couple questions. Rick, go ahead.
Great, thanks for the presentation. So you said on the last slide, you were asking if you should focus on one solution rather than both. Can you clarify what you meant by that?
Yeah, okay. So the two scenarios are the intraoperative guidance system and the procedure training scenarios. So so currently I'm at the first year of my PhD, and also I'm in Sri Lanka due to the COVID situation. I cannot go to the New Zealand. So in case I have to choose one of them, because for the intraoperative scenario, of course, I think I have to go to the electrophysiology lab and use this information and interact with those people in order to kind of develop something and to evaluate something with them. So that's kind of needed. So if I have a kind of situation when so currently I'm doing the user analysis or the interviews with users to get the user requirements. So currently, so if my case is if things happens, if I cannot go to New Zealand during my PhD, so that's kind of a problem that I might have. So if I have that problem, so that's what I'm thinking. What are the things that I should consider if I had to choose one of it? Yeah, that's my aim.
Well, I'll just chime in, and I'm sure other people have other advice, and you'll hear from your mentors as well. Yeah. Interoperative is going to be really hard.
Yeah.
Because even just getting access to the people, let alone access to the procedure, is going to be extremely difficult. I would encourage you not necessarily to not to work on it, right? Because I think ultimately it could be very useful. But within the scope of a PhD, I think focusing on procedure training is likely to be a far better, strategic choice for you than tying your hopes to developing techniques and technologies for interoperative use, which is going to be very hard.
Yeah.
Not to be a wet blanket, but just trying to be realistic.
Yeah. Thank you. Thank you very much.
Another question? Okay, well, thank you so much, Nisal. That was great. We have a few minutes before we're gonna start the breakout, so we could have a little break, which might be nice. Once we come back on the hour, well, I can just open up the breakout rooms now. There should be one breakout room, with your name on it, with each student's name on it. And so for the first breakout session, you'll meet with one of your mentors, sort of the first one listed, I guess, for breakout 1. And then we'll come back after 45 minutes and we'll have our short virtual banquet together, and then we'll open up for breakout session 2. Am I saying everything correctly? Yeah, okay, sounds good. Okay, so let's take a couple minutes break and we'll come back on the hour. And
I don't know if people have food now, Jonathan.
What's that?
I don't know if people got food or not yet, because some people got their gift cards like an hour and a half ago.
Oh, okay.
Does anyone want to share their dinner with us? I have Jersey Mike's, very fancy American cuisine.
Awesome.
I'm jealous. It's been a long time.
Yeah, I'm about to eat some frozen pizza, which is why my oven was smoking, but my smoke alarm was going off. So,
I was like, is it mine or how? Like, I was confused with the sound, of the smoke alarm.
What, you couldn't hear it?
I could hear it. I heard it like a couple of times. I said,
oh, I'm so sorry. I'm going to blow out your eardrums on that one. Wasn't sure what to do. So it's be a Zoom story.
So yeah, I don't know. Are we? Maybe we can get a vote in the discussion chat on if we're having, because I think I gave people the impression that we were having the virtual banquet on this break. And I know it's not exactly a banquet because it's only 15 minutes either way, but we did get free food and we get a bit of fellowship. We get to be a little lighthearted, so that's nice, right? But are people wanting to stay now? I guess if you want to stay, I'll be here. I also have my own bottle of wine. Don't tell anyone, even though this is recorded. It's Friday night in Texas. Okay.
Well, Alicia, we were scheduled to have our first breakout in like 2 minutes.
Oh, okay.
So I don't know what you want to do, but
I'm just going to stay here. And if people want to stay and chat and be social, they can. And if they want to leave, I'll still be here because I'm here.
All right. Well, I will go get a slice of pizza then.
Okay. No one is sharing their dinner with us.
I got some pho. I don't know if it's visible.
Oh my gosh, that's amazing.
But I already ate it, most of it. So
Niall, I'm jealous. I didn't pick Jersey Mike's. My partner was doing something for his job and he ordered this, which I'm very grateful for. But as my aside kind of mentoring, one of the things I'm learning as someone who I have a lab now that's very underfunded until I get some federal funding, but I have teeny bits of money here and there. And like I had the NSF, IEEE VR Doctoral Consortium grant. And then I found out that when you want to spend money, even when it has your name on it at a university, it sometimes takes months for them to say yes. And it maybe depends on the university you end up teaching at. University of North Texas is a Research One institution. That's where I'm at. But we've only been one for like 5 years. So they're a baby R1. So our administrative support is catching up to the fact that we have that. And while it could sound like I'm venting because I am, it's also a mentoring moment because those are things I didn't think about when I was deciding where I was going to go to work, like what the infrastructure would be like.
yeah, that's definitely something that has not ever crossed my mind when thinking about career prospects and stuff.
Yeah.
So it's good to know.
Yeah, and things like your startup package. Like I have a friend who teaches at University of Colorado, Denver, and she's in biology, but her startup package for her lab was like $250,000. And I started with $10,000. So there's a range. There's a range. I know some of us are hiring. I'm not though. Anyone hiring?
Right.
I'm not looking for a job either. I'm just for the DC students.
Right. Augusta University is hiring professors at all levels, so assistant, associate, and full.
You're at UCF now, right, Jason?
Nope, I'm at Augusta University.
Oh, Augusta. Oh, cool. Nice.
And I need more people for the AR/VR lab, so come on, come on.
You guys hear that? I have to get tenure before I consider leaving. Wait, this is being recorded. Don't say that ever in public. Mentoring moments. Don't do what Alicia does.
I have an
Before
innocent
you
piece of
would
advice,
consider.
which goes for people on the job market as well as people who already have jobs, which is always be nice to the administrative assistants and like any staff, because they will break you if you are rude to them, and fairly so too. So when you're on the job market and somebody's like arranging your schedule, that person is the most important person for you to be polite and respectful to. And once you get a job, the same thing is true. It's like that will cause you, it can save you a lot of trouble or cause you a lot of trouble. So always be respectful to everybody, but be the most respectful to the person who knows how everything works and stays for 20 years.
I second and third and fourth that. I put my whole heart behind what you said, Andrea. And like even tonight, some people may know that I was having a crisis trying to get gift cards to people. And it wasn't until after 5 p.m. our time on a Friday night, right before spring break, that it actually all came together. And I'm pretty sure if I were a jerk to the administrative staff, that they just would not have answered those emails. So yeah,
Actually,
it definitely makes a big
I'm sorry,
difference.
but, actually, I'm a little bit surprised that I didn't know you could be impolite and disrespectful to university administration. I didn't know that was an option.
Not for long.
Yes.
But
It's
I've seen
always an
people make that
option.
mistake.
Okay.
Well, similarly, to piggyback on what Andrea said, also be kind to your colleagues in the doctoral program and as you go to these places, because I've heard some conversations on search committees. It's like, oh, I've met them before. No, like you don't, it doesn't even matter what's on your CV. If someone on the search committee knows you and they tell us that you're not the kind of person we want to work with, that's the end of the story.
That kind of goes for everything, not just jobs. It just goes for life in general. Just like I have some stories about neighbors, and yeah, you better be nice to neighbors. They can backfire on you. So yeah, it's interesting advice, I think, and it sounds very, very practical as well. Definitely be nice to everyone. Do some favors for them, maybe. That can help. Lend them some money, maybe. I don't know.
By the way, sorry I missed the last group of presentations. Will we do the one-on-one breakouts in a little bit, or what's the schedule like?
The breakouts, I think, are open. I think that's what Jonathan was saying, that he opened the breakouts for everyone. So this was us hanging out if you're not going into your breakout. I think we have, what is it? There's a 15-minute break. So don't the breakouts start at 8:15 my time? Let me look at the schedule.
Time conversion.
They're scheduled
Yes.
at the hour.
Oh, they are. Oh. My schedule doesn't.
I mean, we could take.
Okay, so you guys can go into your breakout rooms. I know some people already had their breakout meetings with their mentors at different times scheduled. So if you want to hang out here, cool. If you're supposed to be getting mentored, please don't let my meandering keep you in here.
And one more question.
Oh yeah.
So the order of the mentoring for the breakouts, is it just the order in which it's listed on the schedule?
That is the way that we intended it, but also you should have gotten an email connecting you and your mentee and their other mentor in case you guys needed to make any changes to that.
Okay, yeah, got that. Thanks.
What about my first mentor is not here? Should I send an email or?
Did they not email you and tell them they weren't going to be here? I would definitely send an email. Yeah, I would send an email.
Yeah.
Maybe they fell asleep.
Okay. Okay. Yeah, my second mentor is here, Kyle Johnson, but he's meeting someone else. So probably
Okay.
I'll just hang out with you guys for now.
Okay, awesome. Anyone else have advice? I would. I always want to ask Kyle for advice. He's so busy though. Kyle Johnson, your mentor. He does so many cool things. I just want to know more about his choices. I know Dr. Thomas is a great mentor because I've seen him mentoring other students. I'm going to share some life tips. I need guidance. Probably gone. I feel that I may be the only faculty member left in here. Is that accurate? Andrew, are you a faculty member? Are you a mentor? You're a student?
I'm a student,
like,
yeah.
I recognize your name, so I was like, maybe.
I get confused for that a lot, though, the age. And I'm willing to eat ice cream in front of people, so.
Yeah, I think that was the thing, that your comfort in eating, because I'm literally holding a sandwich and I just keep thinking like, am I ready to be chewing on camera? And I know this was actually my idea, but I maybe hadn't thought it all the way through about the chewing on camera. Drinking wine on camera somehow I'm okay with, but
yeah.
Chewing.
Well, yeah, I
Chewing
ate my
is harder.
sandwich. I ate my sandwich during the last presentation, and I muted or killed my camera while I ate the sandwich. But ice cream's okay on camera. So
Yeah, that's a good choice. Maybe I'll take a break and go get some ice cream. Dimitri, do you want to jump in a breakout?
Yeah, I was just going to ask if we wanted to go over to the breakout if this is our time.
Yeah, I just I had trouble figuring out where I was actually supposed to. I just figured it out, and now I have the list of breakout rooms. It's still a little bit confusing for me, the logistics of everything, because we're using so many platforms, and I just figured out the where the breakout rooms actually were. So
Yep, just click on your name and say join. So it's at the bottom, the breakout rooms button.
Oh, okay. See. Oh, here we go. Yep.
All right, see you there.
I have notes that I wanted to contact you later, Niall, but I can't remember what your topic is. Oh, did he just leave right when I said that? Oh, you
me?
just moved. Okay.
Robust redirected walking in the wild. That's
Oh,
what I'm-
yes, that is so exciting. And also a lot.
Yeah, it's hard because if you saw the mesh in that video that we got from the camera, I'm not a vision person, so I kind of just used whatever tools are available for that part. And you know, like I guess most tools in the VR world are kind of underdeveloped.
Yeah.
So getting just a decent quality mesh can be a bit of a challenge. Like if the floors are too reflective, nothing works for detecting the floor plane and stuff. But
And you were inspired by robotics?
yes, pretty much. Yeah, because
So
like
how did that happen?
Yeah, I'm in the Gamma Lab at UMD, and the Gamma Lab is very big.
Okay.
And the PIs they've been in the business for a while now, so they've branched out to lots of different topics. So basically all the students in our lab, a lot of them we work on a lot of different topics, and so like half of our lab is robotics. So in like lab meetings, people present their research, and I realized, and then so during one of these meetings that someone was talking about their robotics motion planning stuff, and I was like, oh hey, this is useful for this thing I did in undergrad, maybe I can do it in grad school too. And
That's so
yeah.
cool. That's awesome. That's a total testament to interdisciplinary work. That's great.
Yeah, most of my ideas just come from other papers that are not VR papers.
Welcome back, Hansi.
I tried the same approach by following like the conventional laboratory setting into like replicating it into VR. So the same textual stimuli to recall the autobiographical memory. And all the reviewers, they just said the same thing, like why, when you're leveraging VR, why not like completely, why just text? And I mean, I wanted to say that text also holds its relevance, even if it's in VR. So, I mean, that also contributes to something, but then it's yeah, it was rejected from many places. So I
Yeah.
think even while replicating the same thing to test out whether it works in VR or not, it's important. I don't know, like the conferences, for the novelty or the contribution they demand is pretty high.
Yeah, I have had some trouble with that in the past where it's like, how do you properly explain why I'm using things from robotics or whatever if it's a VR paper? It's definitely a bit tricky.
Yeah, and the worst part so I'm like doing my PhD in Auckland, New Zealand. So my PhD duration is 3 to 4 years. So I don't know how other are like imagine us to finish the research in one go in 3 years, because I know like research is supposed to fail in the first trial, right? You can't like do some amazing research in the first trial. So that's why, like, I don't know, we don't have much scope of failing. And if we fail and if we try to report, let's say what we are reporting doesn't work, so that other people can't do that. But I don't know how the peer review
Yeah, people
process
don't
works
really
these
like
days.
those papers,
Yeah, they are
right?
like insignificant. Why are you even publishing? Why are you even like trying to submit? So
Maybe
weird.
that should be a new journal. Valiant efforts and STEM.
P-value greater than 0.05.
Benjamin, your breakout room, it doesn't look like anyone is in it, but your breakout room is supposed to be the room with your name on it. And it appears that there are 2 of them, so maybe that's why you're having a problem. Although there's no one in either room. Who are your mentors?
My mentors are Kenny Guchala and Steve Kutchin.
I don't know if,
think
did you have any email correspondence with them? Because I don't know if they were here.
I
Were
don't
they?
think they were here. No.
Okay. So they may have wanted to schedule something, because that was one of the options that we gave for mentors, was to schedule something with you directly if they weren't available.
Okay, I should then follow up on the email.
Yeah, and we emailed you. I think it was either Jonathan or Rajiv who emailed you and copied the mentor. So if you just email them, that
Okay,
would be.
thanks very much.
Thank you. Sorry about that.
No problems.
There's this terrifying button that says close all rooms whenever you open the breakout rooms. And it's bright and shiny. So I want to click it, and it's red, which to me means close or end. And then I'm like, wait, what does this big red button say before I click it? And luckily I have not closed all of the breakout rooms. And I think I'm just going to stop clicking things, because I feel like the night is getting longer and it might happen. And I don't want to be the person who does that.
Yeah,
Also, don't do that.
Last year, I was a TA for a class that was on Zoom, and people would stick around at the end of class to ask questions, which I'm not needed for. I would help during the class to like field questions, because the professor didn't want to read chat while lecturing. And so I meant to just leave the class after and let them talk, but I accidentally ended the meeting for all. And there were like 3 students still waiting in line to ask questions to the professor. And it's like, oops, I don't know what to do at this point.
I know. Yeah. I feel like maybe people are getting a little bit more patient with each other during the pandemic in some ways. In other ways, less. But in some ways, like something like that, I think people might just forgive. Like, it happens.
Yeah.
Now, traffic is another story. I don't think they're getting more patient with traffic during the pandemic. Oh, Benjamin is back.
I just had a question about the PowerPoint, because I had some technical difficulties with getting my slide to work full screen.
I'm here to field questions. What's the question?
So the question is, well, like, given that the PowerPoint was recorded, should I provide a different recording? Because of the recording quality of having full screen in PowerPoint.
That's really up to you. I don't have access, I don't think, to the video, but whoever has the video will be sharing it with the mentors, and I think maybe everyone. I'm not sure who exactly gets a copy of the video, but I know that the participants definitely get a copy of the videos. So you can choose the video that comes from your presentation today, or you can make a new video if you want to, but I don't think that you necessarily need to. That's really up to you and what you think you want to communicate.
Okay, so would I have the opportunity of editing out the user interface thing before?
Well, when we share the video, I suppose you could record it and edit it with Camtasia. I don't know what the format will be when we distribute it though, because unfortunately, that is out of my circle of influence.
Okay, cool.
Sorry.
Thanks.
Thanks.
Do we know if the conference this year will be streamed on like YouTube and Twitch and stuff? Like
I know that we have Twitch. We had Twitch plans. I don't know about YouTube, but I imagine it will be the same as last year because we have lots of people in charge of those things. And last I knew, we had plans to stream to Twitch. Jonathan, are you? I bet Jonathan left. Maybe he's ordering.
Yeah, he went to get pizza, I think.
Oh, that's right. Maybe I'll leave to get ice cream. That's a good idea, Andrew. So yeah, let's write a paper about how oddly different it is to have a virtual banquet online instead of just sitting across from someone who's also chewing. And then we can bring in Jeremy Bailenson discussion of Zoom fatigue and the fact that our heads are so big and my brain is tired.
And you get more conscious of stuff in your teeth than.
Yeah, definitely. It's like I'm pretty, and I have this giant ring light shining on me, so there's not even a shadow to hide behind.
Yeah, the desk I'm at has a mirror right on the wall that's up against, so I see two versions of my face all the time, basically.
Oh, wow.
Yeah.
How do you feel about that?
I mean, I'll live with it, I guess.
You're like, I made this room this way.
It's a hotel, so it's temporary.
Kunal, I think are you talking to us or are you talking to someone else?
No, I'm talking to Prashant, who is in the breakout room.
Oh, okay.
And alone, so I asked him to come out. There's no his I think his mentor is not there yet, so yeah.
We have a scheduled closing session. I don't feel that it's necessary, but Jonathan is in charge of that closing session, so I guess that will be up to all of you. I feel like we could end a teeny bit early.
I'll probably be asleep since none of my breakout sessions are today.
Oh, really?
Yeah.
Yeah, I don't blame you.
I see something that says all the breakout rooms are closing in 20 seconds.
Oh.
I think I did that. I was hoping some of you know how to undo that.
Oh my.
Well, we only have like 10 seconds, right?
10 seconds.
Wow, I guess everyone's coming back.
He got
me.
fished by the bright red button.
I guess, Jonathan, someone just clicked close all of the breakout rooms.
I think we just have to open it. That was a mistake. Sorry, we'll open
guys.
it right back up.
We missed you all.
Long time no see.
Okay.
Hi, everyone. Bye, everyone.
Bye. See? If only the people who created interfaces were also interface designers. Or maybe at least user experience testing people who realize that a big red button compels you to push it.
Yeah, there should be another button that, I don't know, like doesn't do anything.
Yeah. Sandrana's usability heuristics say that actions should be reversible. Oops, never mind. I didn't mean to close all the rooms. It wasn't me, by the way, just in case it sounds like I was confessing.
It was me.
It's funny because before you came back and said that you had done that, I was just talking about how I am trying really hard not to do that because that button is so compelling. I just want to click it every time I open It's like there's a big red button on the button, close all rooms. It just looks like something you're supposed to push. You're not supposed to.
You pushed it.
How far are people from graduation? And I have no idea is a fair answer.
Probably 2.5 years if I'm based off my lab mates' trajectories or timelines.
Nice.
I'm shooting for about
7
10
months.
years, maybe 20 if things go well.
In an ideal world, I'm 7 months.
What? Wow. That is
I guess in New
worthy
Zealand,
of
Australia,
celebration.
we have 3 years PhD.
Okay.
Ish.
Yeah,
I was
so like
going
then
to
how?
ask,
Mhm.
what's the normal length in the US now?
It's like 5 or 6, from what I understand, at least. At UMD, it's I think mostly 5.
Yeah, because in the US, it's just dissertation. There's no coursework. There's no orals or written examinations.
Wait, where?
In Australia and New Zealand,
Okay.
it's just the only thing you do is dissertation.
Oh.
So
Yeah,
there's
we
no
did-
more coursework. There's no oral examinations.
Yeah.
We just started doing this new thing in the College of Information at University of North Texas, where you can do a manuscript style dissertation. And I guess this is common, but I'd never heard of it, where you submit, like after you have 3 published articles, those can count as your dissertation, which to me seems a little odd, but I guess it's a common practice around the country.
You don't really write a thesis, a dissertation, you just hand in your 3 papers and you're good?
Well, you have
No,
to
no.
write up an intro, like explaining how they go together and all that. Bruce, do you know about this process? Because I'm literally
Yeah,
just
our
learning about
university
it.
has it. It's based on a Scandinavian model.
Okay.
So the idea is you do 3 journal publications. Generally, computer science is a little different, but you do 3 journal publications, and then, well, in here, what you do is then you submit those things, and then people say, yeah, that's enough, and then you write an exegesis, is what they call it. It's a description of how all these things fit together and a more comprehensive literature review.
Oh.
So it works. What it works really well for is if you have a collaborator at a national laboratory who is doing research but doesn't have a PhD. So they say, look, just take your last 3 publications and we can bundle it up and make a PhD out of it.
Oh, wow.
The only problem with it from my perspective is that the fact is, let's say you do your 3 publications and you put your last one in, but it takes you 9 months to get all the revisions done.
Yeah.
There's a lot of, not a lot, but a number of faculties here, they just, that's how they do it. They don't write a thesis. It's an option for all of our students. So like my students could start with that from the beginning.
Yeah. It's interesting for me learning this whole process of mentoring PhD students and guiding them in this process. It's different than being like leading the Doctoral Consortium, of course, because you're with the students and they're submitting their revisions and all. And then they made this new rule, and I haven't decided how I feel about it because I feel like it leaves a lot of gray area, but I guess maybe always dissertations have a lot of gray area.
I mean, what are the way? I think one way you could run it is you have the 3 publications and then you submit it to the examination board, and then they say, yeah, that's good enough, just write the exegesis. You haven't passed, but
Yeah.
you've done enough, as it were. But if they're going to say, no, we don't like that, then you just fall back and write a thesis, because you can pile in all the other little bits and pieces that are not in the papers.
That's true.
quick question on that, Bruce. So like when we say 3 papers, does that mean like those should follow the same storyline, or the storyline comes later, or it's just like 3 publications we submit?
Well, they have to be, that's what the exegesis is. You have to tie them all together. So like if I wrote a cryptography paper and then I wrote a VR paper and then I wrote a programming languages paper, you wouldn't get a thesis.
Yeah. So
but go on.
Yeah, I was supposed to finish in January, but then my first 2 papers were on cognitive load and trust, using physiology, same thing, but different from emotion recognition. So that's why those won't be counted as the main publication for the PhD. They are like whatever you get alongside with the PhD as a first author though, but still those won't be counted as a main. So that's why I have to run like 3 other experiments and finish publishing those.
Oh, yeah, no, I don't know what you do when you hop topics, you know. I mean, I think that's.
Yeah, because cognitive load and trust, like both are psychophysiological concepts. So both are psychological, but then they impact physiology as well. So I mean, I was trying to understand how physiology works in the first place, and those topics helped me. And then I ended up publishing those, but I thought I'll use those as a part of my PhD. But then apparently it doesn't follow the storyline, so that's why I have to finish other 3.
Yeah, so I can't. I mean, my one of the papers from my students in the conference has to do. His paper is between cognitive psychology and augmented reality. So it's when we're publishing the papers, we decide to publish it in computer science venues, but they could have equally be published in one of them in a neuroscience journal and one of them in a sleep cognitive science sleep paper. They were valid. We did the work that was valid in both disciplines. So yeah, it's really tough when you cross disciplines.
Yeah, regarding
the other problem in our discipline in computer sciences, and that's why I had to get through the heads of the people who are doing it. It's not unusual that you send the paper off to be reviewed, and then somebody says, "Oh, I'll give it to somebody." You know, it's an EEG paper. Well, I'll go give it to somebody in the neuroscience department and see if this EEG stuff's correct. And so it's like saying, "Oh, we'd never published that in our," so then we reject it in our discipline.
Oh, wow. I mean, I guess it makes sense because you don't want to contribute to misinformation, but sheesh.
No, it's correct. It's just they're going to say, well, you didn't. It's not that the stuff's incorrect, but they're going to say, well, it wasn't done to the standard of, neuroscience or cognitive science, and so it's probably fine for what we want. It's just that you wouldn't publish it in in their discipline. But you're not trying to write a neuroscience paper. You're trying to write a computer science paper.
Yeah, exactly.
I sometimes hate ourselves. I don't know.
So, I think a lot of BCI studies won't be able to publish if we follow the same phenomenon, because like in terms of neuroscience, it's a little bit different. What we do in BCI studies, we're just like we try to find some signal, some activation pattern, and then do it. But neuroscience scientists, I'm not sure if they'll agree to our techniques to that extent.
Yeah, BCI is a good example of how you probably couldn't publish a lot of the stuff in the neuroscience journal because you're not studying, but you're using a bunch of neuroscience techniques to try to get an interaction. But that's a field that they carved out something where they said we are not neuroscience, we are computer science. We just happen to use this sensor. So.
I have a question about this cross department or cross field thingy. So when, let's say if we go out for a job hunt, either in academia or industry, does the department from which you got, like from where you graduated, matters? Like, because I mean, most of our publication is in either IEEE or ISMA or like towards HCI domain, but the degree that I'll be getting over here would be in bioengineering. So I'm not sure if that influenced the chance of job opportunities later on, or how much do they consider?
Well, what ends up happening is, okay, so let's say you get a job in a computer science department where you're going to have to teach computer science. And in my mind, if you get a PhD in computer science, that means you should be able to teach anything in the undergraduate computer science. Maybe not capstone classes, but certainly in the first 3 years, you should be able to teach any course if you studied up on it. If you don't have a traditional computer science educational background, it'd be very difficult for you to do that. So if you went for a computer science job as an assistant professor, you would need to, demonstrate in your application that you could in fact teach, undergraduate courses, that you have that grounding.
Oh, that will be difficult. Because
that's the reality of the situation.
Yeah, because my undergrad was in electronics, and then master's was in HCI, and then PhD is, I mean, it's with Mark, but just the lab is in bioengineering department.
But if you have an undergraduate degree in engineering, and then you have an undergraduate degree, and then you have a master's in HCI, you could make the case to say, look, I have a close enough background that I could teach a lot of courses. The problem, in my mind, the problem happens is you bring somebody in and all they can do is teach in their research area. It becomes a bit of a load for the department. You'll probably be able to teach in that, but you're going to have to, teach, the myriad of other undergraduate classes where they probably don't have actual people doing research in those. Certainly, if you're trying to get a job in Australia and New Zealand, they would look for that sort of that would be a consideration. I'm not saying it would preclude you from it. It's just that that's something you need to be aware
of. So in these conditions, like how much the letter of recommendation or the referral matters?
For what? Sorry, I didn't hear what you said.
So like the letter of recommendation or the referral letters from the researchers I've been working with, or let's say my supervisor, does it matter, or like does it have any impact on the job application?
Your references? Yeah,
references.
Well, should. I don't know you.
So I work with Mark.
No, what I'm saying is that
oh,
if
okay.
you can't, I just looked at your CV, you're going to say you look really good on paper and you interviewed quite well, but then the letters of reference, you have to read between the lines in the letter of reference, but you're going to say, do we really want to, is this person a troublemaker?
Yeah.
Is this person hard to get along with? And you get so you can read the letters of reference to read between the lines. That, I mean, it's that personal stuff that the letter of reference. Also, it's like, I'm not going to give a letter to someone that doesn't deserve the job. So it has that, if you get a letter from Mark, people are going to really respect what he says. Okay. So they're very important.
Okay. So in that case, it doesn't matter if your background, like your degree is in bioengineering or computer science.
It all matters.
Oh.
Yeah. I would add too that like I was just on a search committee and we looked at people who didn't have an exact degree in what we were looking at. We were hiring someone for analytics and personalized learning, but they had a lot of publications in that space. So your publications can offset your education if you have shown expertise.
Well
because
put.
because most of the job description that I see like over the websites, they say like you should have a publication in these like GAI or other HCI related conferences, and then they say you should have a degree in computer science or engineering. But bioengineering, I don't know, like I've never heard about bioengineering before joining this. I mean, I've heard about it, but I didn't know that this could, how different would it be from HCI thing. But so I'm not sure.
I think what you have to do is when you apply, you have to just be very upfront about that. You know, if it's an HCI position, you have been doing HCI research. It's just with this particular flavor to it. Because generally, well, different places do hire differently, but we hire people first because there's a research area we want to build up or extend into, so then you want to hire into that space. So that's why they say those topics, and that's why the publications are so important. Because if you're hiring into an existing group, they're going to say, well, we know what the good publications are, and if you're not publishing in the places we're expecting you to publish, then we don't want you. But if you are publishing in the places, then that shows a competency of getting in there. Then the other part of it is that the department has to say, can this person teach? Can this person, do all the other tasks? Because in Australia, a traditional new academic is going to spend only 40% of the time doing research, and then 40% of their time teaching, and then 10% of the time for administrative duties in the school. So they're desperate to get world-class researchers, but there's all these other duties that they have to be able to do also.
Is it the same situation in the US as well?
Yeah, the 40% teaching, 40% research, and then 20% is service, which counts like university service, service to the community, service to the academic community, all of it, which really, and they specifically say, it's kind of funny, it's not 20% of a 40-hour week, it's just whatever your workload is. So I don't know any, I just, not to be negative, but I don't know any professors who don't work at least 50, 60 hours a week. But the nice thing is I can grade papers from my couch while watching Netflix. So, I mean, not papers, because that would be bad, but I can grade some assignments. Like I can grade a graphic design assignment on my couch watching Netflix. So we work a lot, but then also this I count as work. So I've been doing this all day, but this is fun also. So it's balanced, but yeah, it's not light work. There's a lot to do. But yeah, the balance is pretty much the same. And if you go to, like, if you went to a teaching institution instead of a research institution, which I don't think anyone who comes to these things would really try to do, then you teach even more. So like I was at a satellite campus of Purdue for a few years, and I taught 3 classes and only had like 20% of my job was assigned to research. So it depends on where you go.
Purdue?
A satellite of Purdue. So I was at a teaching campus of Purdue. So there's like the big Purdue, and then there's like Purdue Fort Wayne and Purdue Southwest and these things. I was at a smaller campus, so I taught 3 classes. But yeah,
big classes.
Yeah. And they do expect you to be able to just take on anything in those first years, because it's like, oh, object-oriented programming. You remember that? Sure, I'll relearn that and teach it. Or right now, I haven't used Photoshop in like 5 years, but I redesigned a class that was teaching Photoshop, and I had to, of course, learn Photoshop again to teach the class. So that's fun. I mean, I think if we're all lifelong learners and scientists, so it's fun. I think it's one of the things I like about being an academic is things can change very quickly. And one day when I have money to have a full lab, it'll change even more quickly at my whim instead of the department chair's whim.
But the other thing too is you can, if you go on postdoc for 3 years and then in your postdoc you do some teaching, then you have a track record for teaching in computer science. That offsets a lot of this.
I was about to ask about postdocs and what do we think they're necessary or like recommended? What type? I don't know.
Obviously, if you can jump into a tenure track position at a prestigious university, you just do it. I mean,
yeah.
If that's what you want to do. A lot of people just they just jump right into Google or Amazon.
I had personal reasons to not take. I was offered a postdoc at University of Wisconsin-Madison, and I feel like I would have learned a lot. And I turned it down to take a tenure track position at Purdue in Fort Wayne, this small campus, but I didn't learn a lot because I was learning little things like, relearning object-oriented programming, how to teach it well, and things like that. But when you do a postdoc and you expand on someone else's research, like I was supposed to do this postdoc where I was exploring trust and VR, and that would have been so awesome. And now, before I can do that research, I'm going to have to find funding to do it, where I was supposed to do a postdoc in a lab that was fully funded. So, and that's not like me lamenting my choices. I like where I'm at, but I would just say that's the real consideration. Like the postdoc would have taught me more, but I got paid less. And I also I didn't want to live in Wisconsin. I got paid more with a tenure track position, but I probably would be further in my writing and research if I had taken a postdoc.
Right. Yeah,
so
that was
I agree with Bruce.
I was kind of wondering about this because it's like, if I were to go straight into, let's just say, a professorship job, wouldn't I kind of have to keep doing the same thing I've been doing for my PhD, or like very similar stuff in terms of research output? Like, where's the opportunity to learn something or like branch out into a different research area?
Well, I think there's no tenure in Australia. I mean, you're effectively tenured after, you go through probation, which they put a mirror under your nose, and if it fogs up, you get to stay. But for my understanding of tenure track, in the US, if you're on tenure track, then you just have to bust your ass for 5-6 years. So, and changing disciplines
would be counterproductive to that. Yeah.
It depends. The other thing too is if, let's say, you're doing this health, a medical focused VR work, and you jump into a group that's, is doing digital twinning, which is similar but different. But you're jumping into a massive group like down at, UNC or something like that. Then what ends up happening, they're all going to help you succeed.
Oh yeah, I guess that's true. Yeah.
So yeah, you're gonna have to work a bit harder to do that. But if you join a well-funded group, then you're gonna get PhD students, and
Yeah, that's true. I didn't think about that.
Yeah, but then also to get tenure at UNC is much more difficult than getting tenure someplace else. It was also a lifestyle thing too. But I think if you talk to people who are at Columbia or Stanford or something like that, they all love it, but they made it through the fire.
Yeah.
So yeah, I like it in sleepy old Adelaide. It's the other thing too, which is I got into academia, I think at the exact right point. I mean, you can do world-class research from anywhere. So, and you might have to change what you're, looking at, but except for paying for the PhD students. I mean, VR research is dirt cheap to do now. So that's the other thing too, is like, I'm a big fan of thinking a lot about that old, where do you want to be 5, 10, 15 years from now? And what do you want to be doing?
Right.
You know, well, just look at the little bit I know about the University of Texas, you know, situation down there. It makes a big difference which campus you get on.
Mm-hmm.
You know, I would imagine University of Texas Austin there's a different driver down there than it is at different campuses. Is that true?
Well, I'm at University of North Texas. Is someone else at University of Texas? I think I mentioned earlier, because we're a baby Research One institution, we have like growing expectations that we meet the trends of R1s, but maybe not the infrastructure support to do so. So that, I think, is probably the biggest complaint that I hear of my tenure track colleagues who don't have tenure yet. But I also, like, for instance, like what Bruce is saying, there's so many trade-offs, because at my institution, in my department, we have a lot of PhD students who just want to get something written. So I haven't leveraged this in the past, but my dean has given me some really good advice. It's like, just pull them in. So like, I have maybe 14 students now involved with my lab. So, and yes, I have overcommitted, but like, so 14 students, so like 6 students are like, oh, I really like this work you're doing on VR fitness, and I'm going to help you run some studies, and I don't have to pay them. And then I have students who are like, oh, I really like the summer camp you're doing. And then I have 10 undergrad students in the capstone classes making a game that I designed as their senior capstone project. So sometimes, like, I don't have the resources that like someone at like Stanford or a regular Purdue has, but I have different resources. And it just took me a while to figure out what they were and figure out how to leverage them. So wherever you go, you'll be able to do that, because that's what we are. We're problem solvers. So you'll figure it out.
That's great advice, because a big thing in Australia is PhD students are free. I don't have to find money for them. And other people complain, I can't get any money. And I say, well, just go get some PhD students. You don't have to pay for them. You know, I talked to Feiner, and he's like saying, I'd have to find $1 million to get the number of PhD students. So yeah, that's you play to the strengths of where you are.
And I talked to Andrea about this a lot, and it is also true that having PhD students, particularly if they're early in the process, is sometimes as much work as doing things yourself. But we're also mentoring people to be our colleagues, so it won't always be like that. And Andrea's not saying anything, so maybe she's not here, because I feel like she would have said something.
What was the question originally?
What was the question?
I asked about postdocs and like being able to do something different from your thesis, and then it morphed into whatever we started talking about, I guess.
Okay. Did anyone talk about like funding your own postdoc through a fellowship, and then you can do whatever you want?
No, I forgot that that's an option. Yeah. What?
It's tough. Yeah. So, I mean, I got one through Osaka University in Japan through the Japanese government. But I think NSF has similar fellowships.
Yeah.
It'll give you your postdoc, and you decide your own topic. I mean, you have to propose it to NSF, and then accept it. But and then you get to do whatever you want for a year.
Do you still have to find like a supervisor for that still, right?
Yeah, you have to do it as generally, I think, as part of a lab.
Yeah.
And then maybe the folks that have been in the US longer can speak to this more. But yeah, mine was, I had to stay at my current lab in Osaka University or have a lab that sponsors you, basically. But the lab doesn't pay for it, so
there's
not that much control.
Yeah, I forgot that that's an option.
How do you convince them that you're worth their money? What did you do?
Oh, and it's in Japan.
Like Osaka University.
Yeah,
So how did you convince them that they, or whoever had to, who paid for that? Like who paid for that?
So JSPS, Japan Society for Promotion of Science, and they have different mechanisms. They have DC1, DC2, PD1, and PD2, which is first year doctor application, second year doctor application, and then postdoc application, and then like advanced postdoc application. And I didn't get it. I applied for my PhD for them to pay for the last 2 years of my PhD. Didn't get that. Revised it, did it again. And by that time I had journal papers. I think I had two. I had like one, like a journal paper, a conference paper, and then a journal paper that was tentatively accepted or something. And that's apparently their standard. And then that paid for 1 year of PhD and 1 year of postdoc. So it wasn't much, but I wanted the freedom. I wanted to publish my own work. And so, yeah, that's how I got it.
That's really cool. I don't know what the schedule is anymore. Jonathan, can you help us? Because
I think we're on our official break right now. Until the top of the hour, if I'm not mistaken.
And then how are we feeling about this closing session? The 15 minutes of coming back. Do we need to do that, or are people just going to be free to leave after their next break?
They're kind of flexible. I think for some people, their mentors actually have arranged a different time to meet with them anyway, you know, so.
I think I may become absent shortly.
Likewise.
What time is it for you, Alicia?
8:53. It's not too bad. I was planning on being here until 11, and then I realized that I don't have anyone to mentor in the breakout session. So if we're not having a closing session, and also I realized that even though this virtual banquet was my idea, I feel super awkward eating on Zoom. So I have this sandwich that I can't eat until I stop being here. And I also feel awkward about turning my camera off because this is supposed to be establishing relationships and all. So I'm like, I'm going to keep my camera on and drink wine and starve.
Well, Andrew,
what my kids do is they kind of like dip down and they're eating like this.
Oh, that's good.
That's awesome. I love it.
Up the nose kind
Wait,
of
let's see what happens. Oh my goodness.
We need a little like a mask halfway through the frame to let us do that.
Yeah, I don't like eating on camera either.
If I can grab a banana, will you eat with me, Alicia? Oh, you already are? Okay, let me grab a banana. I think that's the most embarrassing food you can eat on Zoom too. So.
So only if we had a technology that would add extra graphical information over top of our visual. If only we had this technology.
Oh, wait. Now I have to do the thing. Where is this?
Cheers.
Cheers. Social pressure is important.
Right.